Turn on the beast mode because we are going to target 150 plus in physics, and for that you need to ace in modern physics, and for that I'm here live with you on the V Biotonic channel. कैसे हो सब लोग, बच्चा लोग, my warriors? Good morning, good morning. I'm Shreyas. I'm the physics master teacher. I'm also leading the physics department, and I have been training kids for a very long time. And काफ़ी सारे मेरे बच्चे जो है, they have not only just cleared IITs or cleared into all these amazing entrance examinations with decent marks, but many of them have got top all India ranks, and that's my aim. अपना टारगेट क्या है? आज का टारगेट है कि भाई नीट जो है एग्जाम अपने को फोड़ना है. सो इफ यू वांट टू क्रैक नीट 2021, this is the session that you should be attending. Last lecture, beast mode session, we had started ray optics. We did ray optics. It was a big marathon session in the night. So मैंने सोचा यार अगर मेरे को लेक्चर बड़ा भी करना होगा तो मैं सुबह आ सकता हूँ. इससे क्या होगा कि मतलब in case even if I extend the lecture, you guys won't be sleepy, है ना? So I hope you guys had your amazing breakfast and you guys are all energetic. Nice to see some of the enthused crowd also over here, like Anaga I can see, and Yalini I can see, Zayad also I can see. Welcome Saili, welcome Yoshri, Shruti, BU, hello Prerna, hello Aishwarya, hello Rashmi, hello Nishchita, Vidya, Bhanu, welcome Love, hi Mad, MIT, nice to see all of you, hi Neetu, hello Aparijita, hello Vicky, hi Vidya, hello Avita, Ria, Pramod, Maria, Saloni, welcome guys. Good morning. तो जोश should be high because आज भी एक बड़ा सेशन है. Like you can see, we're going to start with photoelectric effect, photons. फिर wave particle duality पर जाएंगे. Then we'll also go to X-rays, atomic structure. फिर एक बार atomic physics हो गया. Then we'll go to nuclear physics. And nuclear physics होने के बाद nuclear physics and radioactivity will go towards semiconductors and logic gates. चाहिए कि नहीं आपको semiconductor logic gates? In a very short summary, only the important points. It's not going to be like a proper lecture. See, this is mainly to understand the key points. तो summary points समझने लायक जो आपको formulas हो important, कैसे apply करना है, how to actually implement those formulas for solving problems. Because अभी वो time नहीं है जहाँ पर where you sit and attend atomic structure का 3-4 घंटे का लेक्चर, न्यूक्लियर फिजिक्स का 3-4 घंटे का लेक्चर, एक्सरेस का 2-3 घंटे का लेक्चर. यू कैन नॉट डू दैट. अभी टाइम नहीं है. अभी अपने को एकदम बीस्ट मोड ऑन करना है बिकॉज टाइम इज लिमिटेड, टाइम इज प्रेशियस. सो लेट्स गेट गोइंग. एंड इफ यू वांट टू नो मोर अबाउट मी, यू नो व्हाट टू डू. यू कैन फॉलो मी ऑन माय Instagram handle, that's Shreyas_Vedantu. That's where you can stalk me. All right. In case you are interested and you want to let your friends also know what we are doing on my regular channel, which is VNthus. So you will see me doing the short session, even the physics mock tests, etc. for the JEE mains. So if you have your friends who are preparing for JEE, जो JEE के लिए prepare कर रहे हैं, I regularly teach on my Enthuse channel, which is an English medium channel for all the JEE aspirants. So that's what we are going to do. Even some advanced level sessions are also going on right now on the channel. This is the schedule which is there. All right, let's start first with photoelectric effect. Yes, Vamsi, the classes are going to be in English, bacha. Okay, yes, Gen C, yes, the classes are going to be English. Don't worry, 99% English, 1 or 2 lines probably in Hindi. Don't blame me for that. Okay, no, Abdul, it's slightly different, okay, but it's a good time to actually revise modern physics if you are a NEET aspirant. So there are a lot of NEET PYQs which I have collected, so which will be very useful, and you will understand how the questions can be solved. Especially when you see the PYQs, you get that confidence कि अच्छा ये problem मेरे से बन जाएगा. तो चलो चालू करते हैं. सबसे पहले photoelectric effect के बारे में बात करेंगे. So see, at the end of the day, what is this photoelectric effect? This entire thing is based on one simple thing, and that is energy conservation. Understand the process, understand it in a brief summary. Whatever I am going to tell you, you will never make mistakes. So what happens is, whenever light falls on a surface, whenever light falls on a surface. So what is light? Light is nothing but made up of photons. So photons के पास there will be some energy. It falls on a surface. Those surface will have some atoms, and each atom has nucleus and electrons revolving around it. If these photons can collide with these atoms and they have enough energy, the photons collide with these atoms and they have enough energy to knock out those electrons, then you will see if the photons have enough energy, the electrons get knocked out. So these are knocked out electrons, and these knocked out electrons will have some velocity, also the kinetic energy. And if you think about it from energy terms, here is what one would think. जो भी energy photon के पास था, so the energy of the photon would have gone into, number one, to knock out that electron from the orbit of the atom, you need some energy. To knock out that electron from the orbit of the atom, you need some energy. What is that energy called? That is called as the work function, phi. So that is basically the energy minimum which is required to knock out the electron from the atom. So there will be some more energy left. Understand, my energy by the photon might be 5 joules. Maybe only 2 joules is required to knock it out. So remaining 3 joules kahan jayega? The remaining 3 joules will be with the kinetic energy. So the kinetic energy of the electron. So this is nothing but an energy equation at the end of the day, which is also called as the photoelectric equation. So now if you see, this energy of a photon is h nu, or some people also write it as hf. So these symbols are used interchangeably. So h nu or hf, one and the same thing. It is also hc by lambda. This comes because of the fact we all know c is nothing but nu lambda. Nu is over here the frequency. Keep this in mind. So this is the frequency. The momentum of a photon is h by lambda. I hope you remember this. This is your de Broglie equation in a way. Momentum is h by lambda, या lambda is h by p. And if you notice over here, यहाँ से h by lambda, ध्यान से देखो, what is h by lambda? H by lambda is E by C. So it is nothing but E by C. So both the formulas will work. Okay, so this is how it works. So this is the energy of your photon. This is the energy of the photon. Keep this in mind. Okay, next up, the maximum kinetic energy of the photoelectron emitted will be h nu minus phi, which is the same as this equation. If you just rearrange it mentally, you will see that. Just take phi on the other side. So you can clearly see k max plus phi is h nu. Everybody agrees to this point? Everybody agrees to this point? Correct? Very clear. So h nu, which is the energy of the photon, will be work function minimum energy plus the kinetic energy max. Very good. Next up, ध्यान से देखो, threshold frequency. ये threshold frequency आया क्यों? Okay, see, understand, if the light does not have enough energy, to knock out that electron, the light falls. Maybe the light has energy of 5 joules, but the energy required to take that electron out is 7 joules. The energy required to take that electron out is example 7, but the energy of light is only 5. It cannot push it out. So it will be like, sorry boss, no photoelectric effect for you. So the light should have minimum energy. And what does the energy of a light depend on? It depends on the energy of the photon. That means the frequency. I just told you, energy of a photon is hf. So that's why you will see that the work function is h mu naught. What is this mu naught? This is the threshold frequency of that light. Below this frequency, no photoelectric effect will occur. After this frequency only, the photoelectric effect will just start. Everybody clear about this? Yes, Pradeep, oh my god, this is interesting, Pradeep. When I take JEE lectures, NEET students will ask me, sir, is this useful for NEET? Now when I am taking NEET lectures, students ask me, sir, is this useful for JEE? My answer is yes, every time, because these equations, whatever the graphs, nothing will change, be it NEET, be it JEE. Alright, cool. Very good. Alright, so let's get going ahead to the next one. Stopping potential. Now what is the stopping potential? See, just imagine this. Imagine light had energy of 7. Light had energy of 7 joules. Imagine. Surface needs minimum 5 joules of energy to knock out that electron. So out of 7, 5 joules just was spent to take that electron out. Chal bhai tu bahar aa. Okay, to just take it out. Bacha kitna? How much is left? 2 joules. So where will that 2 joules be? 2 joules will be with that electron. So that electron now has kinetic energy. Now you become evil. You're like, hey, you electron, you stop. So what do? You apply stopping potential. So that stopping potential will take away electrostatically, the kinetic energy of that electron. So stopping potential, you create a potential difference, you create a field so that what happens, whatever that electron is being emitted, that energy is sucked away because the electric force will stop it, because it will oppose the motion of the electron. So that is nothing but the stopping potential, and that completely depends only on the kinetic energy of the electron. Understand that? Yes. So it will completely depend on the kinetic energy of the electron. Keep this in mind. So that kinetic energy maximum which will come will be E into Vs. Remember, always in electrostatics, energy is charge multiplied by potential. Charge multiplied by potential. So kinetic energy will be charge, which is electron charge, into potential, which is stopping potential. That's how it works, and this has always been true even in electrostatics. Yaad hai ki nahi? Everybody? Yep. No, Nivedita, I'm not at all tired. Bacha is probably, I don't know, just this is how my morning look is probably. Okay. So I have just come out from a jog and all of that. So maybe I look, oops, don't save this. I don't want to save this. Okay, cool. Great. Last thing, de Broglie wavelength over here. Now see, what did de Broglie say? If this is the momentum for light, this was the momentum for light, you just shift the terms. Take lambda on the top, take momentum below. Then this equation also works for particles. So particles have wavelength which is called as the de Broglie wavelength. This lambda is the de Broglie wavelength. It's also the wavelength. It's also called as the wavelength of matter waves. Matter wave. Now what does this mean? Please understand the significance of this slide. Light has multiple personality disorder. What does light have? Light has multiple personality disorder. So what are the two personalities? The two personalities are particle and wave. Sometimes light shows particle-like behavior, sometimes light shows wave-like behavior. When I say it shows wave-like behavior, that means things like refraction, interference, then your diffraction. All these are the properties of waves. When light passes through an obstacle or it passes through a hole or a slit, it spreads. That effect is called as diffraction. When light changes the medium, it bends. That is refraction. When two light waves meet, they interfere. That is again wave phenomena. But particles have different characteristics. Like when two particles collide or meet, they exchange their momentums. Correct? They apply impulses and the total momentum is conserved. Similarly, when particles meet, they apply force. Similarly, it is found that when light passes through a corner or a hole, it spreads. That means diffracts, or it meets and it interferes. So it shows wave-like characteristics. But the moment it falls on a surface, you will see there will be momentum. You will see those particles collide and they apply force on those electrons, they knock them out. So that is particle-like behavior. So it shows both kind of behavior. So the significance of this equation is that light shows particle behavior as well, because light possesses momentum. That's what the significance is. Remember, waves do not possess momentum. पार्टिकल्स पोजेस मोमेंटम। तो लाइट के पास दो नेचर है, ड्यूअल नेचर, एक बार वेव एक बार पार्टिकल, तो जब चाहे वो अपना अवतार निकाल लेता है। Similarly, even particles have two kinds of nature. So let's say this pen or you or anything, dust particle or maybe a proton. Proton is a particle, but proton के पास भी दूसरा behavior है, and that is the wave behavior. The wave nature of a matter is called as the matter wave. The wave characteristic of matter or any particle is called matter wave, and that wavelength of that wave is given by de Broglie equation, which is lambda is equal to h by p. Everybody clear till this point? Can we go ahead? ये slide समझ में आ गया? All right. Then let's talk about this particular graph as well. Yes, let's talk about this particular graph. Very important graph for all of you. So over here, like you can see, my warriors, observe there is stopping potential and there is frequency. How do you get to this equation? That's not a big task. Think the h into, let's say, the frequency, which is the energy of the photon, will go into work function plus the remaining into kinetic energy. Correct. Now I can also write hf is equal to phi plus, okay, phi also I can write something like this, hf naught. Why hf naught? That's the work function. This is the threshold frequency plus the kinetic energy. Kinetic energy is the charge into stopping potential. Just let's rearrange these terms and see what do we get. So I will get EVS. Okay, EVS. Take this guy over there. So it will become HF minus HF naught. All right. Now divide the entire equation with E. So I'll get VS. Okay, is equal to HF by E minus HF naught by E. This is very, very interesting. This is very, very interesting. I'll tell you why. Because if you look at this equation, it resembles the equation of a straight line. Try and recollect what was the general equation of a straight line in terms of slope and intercept. It was y is equal to mx plus c. Now you'll be wondering, sir, what is y, what is x, etc. Look at the y-axis, it's stopping potential. So this y is nothing but the stopping potential. Then look at this, what is x? X is this variable which is frequency. Look at this, this is the frequency. The slope m is nothing but this h by e. Can you see that? That slope m is h by e, and that intercept which is there, this c, is nothing but minus hf naught by e. Now it makes sense. Oh, if I draw a graph of potential versus the frequency, then it should be a straight line whose slope is h by e, because m is h by e. Dekh lo, h by e. Correcto. And you can see the intercept where it intersects the y-axis is negative. If it is negative, that means it should hit here. So that's why you can see the graph starts from over here, which is minus phi naught by e. This hf naught is actually phi naught, or just phi, or work function. So this is work function by e, which makes sense, total sense out here. So this is how it is. If you change the material, if you change the surface, if you change to a different metal, then remember one thing, the graph will shift but not the slope. The slope never changes. Observe what the slope is, h by e. These kind of questions can come in NEET examination. If a different metal is used, then the slope will increase, decrease, or remain same. The answer will be remain same, because you can see through this equation h by e is a constant. Next up, if metal changes, then the work function will change, and if the work function changes, f naught changes, and if the f naught changes, the intercept changes, and if the intercept changes, the graph will shift, but without changing the slope or the steepness. Is that clear? Okay, so if you have a different metal, if you have light which is falling on one metal and now the same light is falling on some other metal, you will see the graph will shift, but it will never bend. Okay, clear? All right. Excellent, excellent, very good. So that's mainly about photoelectric effect. Let's get going ahead. Now let's talk about atoms. Like I'm telling you guys, we are just quickly revising through the theory. I'm pretty sure you all want that theory revision, all those intricate details which were there, probably which you would have forgotten, and also these slides will be available to you to download as a PDF from your Telegram group as well. All right. Okay, and immediately we are going to start with problems. Remember, it's a big lecture. We're going to start with this atomic physics, then we are going to go to nuclear physics, and then we are going to go to semiconductors and logic gates as well. Okay, great. Yes. Now, quickly going through atoms, the energy of nth orbit of Bohr. So first of all, before going to these formulas, here is what you should go back at home and revise. So at home, this is what you should revise. Revise the postulates of Bohr's model. Just go through all of it, Bohr's model, and also all the models of atom, okay. So right from the Rutherford's experiment, all right, then all of it, just please go through it. It's pure theory part. They might just ask like what was Thomson's model, or probably it could be a direct GK kind of a question. You never know. All right, now remember one thing, this formula is not needed. That's why I deliberately put it over here, because a lot of people remember this formula. No need to remember this formula. The only formula you need to remember is this: minus 13.6 z square by n square. You should know who is on the top, who is below. Electron volt. Please do not forget the unit. It is not in joules, it is in electron volt. Okay, so this clearly tells me as n increases, the denominator increases, this ratio decreases. So if n increases, this whole ratio will decrease, correct? But it will become less negative. So energy as a whole will become less negative. If it becomes less negative, has it increased or has it decreased? Come on, my warriors, let me know in the chat box. Come on, think about it. Yep, please let me know what will happen if n increases, this ratio decreases, but because of the negative sign, it will become less negative. If it becomes less negative, that means it has become -5 to -4 to -3. It has actually increased. Think about it. Less negative means instead of being very negative like -5, -10, you have become less negative, -1, -0.5. So remember, -1 is more than -5. Everybody knows that on the number line. So it has become more. And it makes sense, because if n increases, that means you have gone to a higher orbit. So you have gone to a higher orbit. Keep this in mind. All right. Also keep this in mind, the energy, total energy, remember this, is nothing but negative of kinetic energy. I hope you remember this. And it is also nothing but half of the potential energy. Very, very important formulas. Some people also remember potential is twice of energy and kinetic is negative of total energy. It's one and the same thing. All right, whichever form you want to remember, but remember this. All right. Similarly, let me also tell you, you don't have to remember the actual formula for radius. Just remember, it is proportional to n square by z. It's proportional to n square by z, because when the radius increases, n will also be more. If you go from first to second to third orbit, imagine n will increase, so radius will also increase. So it is proportional to n square by z, and that constant is 0.529 angstrom. In fact, this is the radius of first orbit of whom? Of hydrogen atom. Everybody knows this. 0.529 angstrom is the radius of the first orbit of hydrogen atom. Next up, angular momentum is always in the integral multiples of h by 2 pi. So any orbit you take, the electron will be revolving, and any object that revolves, it will have angular momentum. Remember, this L is nothing but mRv. You would have studied this in rotational mechanics. This is nh by 2 pi. What is this n? N is your orbit number. K is 1, L is 2, and so on and so forth. Remember, whenever the electron jumps from one orbit to the other orbit, there is a photon which is emitted. So, please remember this. It might sound very trivial or very stupid, but I feel that we need to discuss this. Okay, just think about it. If I label these orbits as 3, 2, and 1. Okay, just think about it. If an electron jumps from here to here, if an electron jumps from 3 to 2, okay, then the photon which is emitted, photon will be emitted, it's going from high to low energy, that will have that photon's energy will be energy of the third orbit minus energy of the second orbit, correct? Similarly, if an electron jumps from the second orbit to the first orbit, if it jumps from the second orbit to the first orbit, then the photon which will be emitted will be having the energy of 2 minus energy of 1, high minus low. But if the photon jumps from 3 to 1 directly, then how many photons will be emitted? 3 to 1, if it jumps directly, how many photons will be emitted? Come on, my warriors, think about it. Okay, how to change from electron volt to joules? I'll let you know, Nityashri. Just give me 1 second. Let me just finish this and definitely I'll help you out with that. How many photons will be emitted? Come on, my warriors. Let me know. From 3 to 1, how many photons do you think? Zaid is saying 4. Alright. No, I know the energy will be E3 minus E1. How many number of photons I'm asking? Ananya is saying 4. That's wrong. Keep this in mind. Every transition only takes 1 photon. Either it will emit or it will absorb. Only 1 photon per transition. A lot of people have got this question wrong. So that's why I thought we should discuss this. So the photon which will be emitted, will have energy difference of 3 minus 1. But still it's 1 photon. Here also it was 1 photon. Here also it was 1 photon. Remember, no matter how high to how low the transition is, per transition there is only 1 photon. But if the electron decides, no, I'm not going to jump directly, I'm going to jump first to 2 and then from 2 to 1. If it makes intermediate jumps or if it takes stops, then the number of photons emitted will be more. I hope this is clear. So if it first jumps from 3 to 2, 1 photon. If it then jumps from 2 to 1, then 1 more photon. So totally 2 photons will be emitted in that case. That's how it is. Why? That's how photons work. So photons always are emitted in an event. You will never see 2 photons coming out of a single event or 3 photons coming out of an event. That's the property of the photon, guys. Okay, cool. Let me just reduce the AC temperature, just 1 second. Okay, cool, great. Okay, now somebody was also asking about how to convert from electron volt. So yes, Geetika, like I said, it will be 2 photons if it was indirect jumps. But if it was 1 direct jump, it will be only 1 photon. So remember, read the question, what kind of jump is happening, and depending on that, you have to figure out how many photons or what are the energies. Okay, now, so in case it jumps from 1 to 3, somebody is also asking, in case it jumps from 1 to 3, how many photons will it absorb if it jumps from 1 to 3? Well, if it directly jumps, if it was direct jump from 1 to 3, then it would have absorbed only 1 photon. But if it jumps from 1 to 2 and then from 2 to 3, then it would have absorbed 2 photons. That's how it is. But no matter what, the energy of this photon will be the sum of the energy of these 2 photons. Everybody agrees? The energy of the jump from 1 to 3 will be the same as the energy of 1 to 2 plus energy from 2 to 3. The sum of the energies will be same. Okay, clear. So 1 photon is 1 transition. Correct, Shruti? Excellent. Alright. Now, everybody agreeing to that? Somebody was also asking, how do I convert electron volt to joules? See, for example, if it is 2 electron volt, remember, whenever you see this E symbol, right? Think E is that standard value. What is the standard value, guys? The standard value is nothing but 1.6 into 10 to the power minus 19 coulomb. So that coulomb will come here and that volt is there. Now 2 into 1.6, that's nothing but 3.2 into 10 to the power minus 19. 1 coulomb into 1 volt is joule. 1 joule. So that's how you convert it. Okay. Similarly, if somebody had given you something else like 4.2 into 10 to the power minus let's say, or anything like this, like say for example 16 into 10 to the power minus 19 joule. Convert this joule into electron volt. So this will be written down as 16 into 10 to the power minus 19 into Coulomb volt. Just write it down like this. Now just divide it by E and multiply by E, or you can just think about it. You know what you can do? This is nothing but 1.6 into 10 to the power minus 19. Okay, this is Coulomb. Okay, and also this you can write it as 10 volt, because 1.6 into 10 will become 16 as it is. So this will become 10 electron volt. All right, is that clear? That's how you need to do it. Great. So you can divide it also and do it, but the idea is E is nothing but 1.6 into 10 to the power minus 19 coulomb, and 1 coulomb into 1 volt is nothing but 1 joule. That's it. That's what you need to keep in mind. Okay, going ahead to the next one coming up on your screen. This chart is very important with regards to energy. Now everybody knows this chart. I'm pretty sure that the Lyman series is when any electron transits from any higher orbit, even from infinity, but it goes to first orbit. So all those series of wavelengths which come out are called as Lyman series. Balmer is when any electron transits from any higher orbit, not from the lower, okay, not from the lower, from the higher orbit to the second orbit. And when any electron transits from any higher orbit to the third orbit, not from the lower one, then it is called as a Paschen series. And bracket is when it comes from any other higher orbit more than 4 to the fourth orbit. That's the bracket series. Now keep one thing in mind, the spacing of the lines is not the same. So if this line has some spacing, the next two lines have less spacing, less. So that's how the spacing works. So this is particularly important for problems which involve, you will see there will be few questions today which will involve the distance between these lines is not uniform. So based on that you have to make certain assumptions and then solve the problem. So keep that in mind. Okay, lastly the wavelength which comes out. Remember, whenever this transition happens, so there is a photon which is emitted. Obviously this photon will have some wavelength. 1 by lambda is rz square, 1 by n square minus 1 by m square. What is this r? This is nothing but your Rydberg's constant. Rydberg's constant, okay? This is your Rydberg's constant. All right. Now this z is your atomic number. N and m, what are these n and m? These are your first and second orbits, the initial orbit and the final orbits. Now if you are confused, sir, is n the first orbit or m the first orbit? Let me tell you, don't worry about it. If you get a negative answer, just make it positive. That's all. Just substitute something, whether it is 1 or whether it is 2, doesn't matter. Just make sure that your final answer is positive. Okay? Don't have to remember, sir, whether it was n was the last orbit, the final orbit, or whether it was the initial orbit, doesn't really matter. Okay? Just put a mod symbol over there. Okay, great. Going ahead to the next one. Get ready, guys. All right. Yes, take positive. Correct, Shivleshi, mascot. All right. Ananya is on fire. Can you please say about the longest line of Lyman or the smallest line of Balmer, like that? Okay, Nityashri, fine. Let me tell you this. Longest line of Balmer, shortest line of Lyman, etc., etc. Okay, this is how you need to look at it. Okay, just look at maybe, let's say, Balmer series. Okay, let's take a random series. Let's say Balmer. Okay. Now, if I ask you, what is the shortest? What is the shortest? This is, I'm talking about the Balmer series. So for the Balmer series, what is the shortest wavelength? Okay, now think, lambda and energy are inversely related. Okay, keep this in mind. Delta E is hc by lambda. So if you want the shortest wavelength, that means you want the biggest energy gap. You want the biggest energy gap. So biggest energy gap will happen when this line is very long. When will that happen? When n comes from infinity to the second orbit. So this is when you get the shortest wavelength. Okay, clear? Similarly, if they ask you, okay, when are you going to get the longest wavelength? Longest wavelength means very small energy gap. How will that small energy gap occur? When the transition is from the immediate neighbor higher orbit. So from 3 to 2. So from 3 to 2, you are going to get the longest wavelength. I hope now it is clear. Very good. Very good. Excellent, guys. Great. Let's get going to the next one coming up on your screen. Okay. So This is all about your X-rays, very, very important formulas. Okay, just one second guys, let me just drink some water. Okay, Priya, you're asking what Rydberg's constant value? Rydberg's constant value was 1.097 into 10 to the power 7. Okay, that's your standard SI unit value. Okay, cool. Now coming to X-rays, see, in X-rays setup what happens is you have an electrode over here and you have a target material. You pass some current over here, and that current makes sure there are some electrons which are moving. There are electrons which are passing through this electrode, or this filament you can call this. There is a filament, and what you do is create a very strong voltage difference, a very high voltage difference between the target and the electron. When you create very high voltage difference, there will be a breakdown. These electrons will start moving and they collide. All right, they collide with high velocities. Okay. Now, similarly, what happens is the moment, this is something like your photoelectric effect, but in photoelectric effect, what used to happen is light used to fall on a metallic surface and electrons used to come out. Try to recollect. In photoelectric effect, what used to happen, guys? The light used to fall on the metallic surface and electrons used to come out. This is exactly opposite of that. Electrons will come and hit the target, and you will see that light, which is nothing but X-rays, will come out. The energy of these X-rays comes by the acceleration of this electron via this potential difference. So that energy of the X-rays is only coming because the energy of the electron, which it gains because of this potential difference, that kinetic energy, when it hits those atoms, they emit photons, and those photons are in the extremely high frequency range or very short wavelength. That's why they are X-rays. That's all. All right. Going ahead, the X-rays which come out are of two types. One is continuous, the second one is called characteristic. The continuous X-ray is the one over here. Look at this one. Okay, this one is nothing but the continuous X-ray. So this one is called as the continuous spectrum, and the characteristic one is the one with the peak. So these are called as the characteristic, X-rays. The continuous X-rays depend on, what do these continuous X-rays depend on? They depend on only and only one thing, and that is nothing but the potential difference. They only depend on the potential difference of acceleration. And you can see that in this formula. This lambda, which is the least wavelength, this lambda naught you can say, or cutoff wavelength, is hc by ev. That's it. This lambda is hc by ev. Now if you are finding it difficult to remember this formula, let me make it little bit easier for you. Think of it this way. When you accelerate that electron, how much energy will it have? Charge into voltage. That energy will go in that photon which is emitted, which is for the X-ray. What is the energy of a photon? hc by lambda. Take lambda on the top, take ev below. So you will see lambda is equal to hc by ev. So that is the smallest wavelength which will be emitted. All other wavelengths will be more than that. That means all other energies will be less. So understand, when the wavelength is large, energy is small. So that is this wavelength corresponds to the highest energy of the X-ray which will come out. All other X-rays will be lower than that. So that's why this is called as the cutoff wavelength of the X-ray continuous spectrum. Understood? Is this clear? This only depends on the potential difference. What do these characteristic lines depend on? Come on, my warriors, let me see if your brain is active. What do these characteristic rays, X-rays, depend on? On what things do they depend on? What is it that changes this characteristic. Think about it. What does this characteristic X-ray depend on? All right, let's see. Subarna Prince, okay, very good. What does this characteristic depends on? No, it does not depend on the frequency. It does not depend on acceleration. It depends on, it depends on Z. It depends on, yes, it depends on the target material. So this characteristic only depends on the target material. Keep this in mind. That is basically the Z. And there is a formula for that. So this is what you will use for the characteristic X-rays. The frequency will be A into Z minus B whole square. Some people also remember it like this. Instead of putting a square here, you would have seen this root of F over here. Root of F over here. Alright, it's nothing but also called as the Moseley's law. Moseley's law. It's one and the same thing. Okay, whether you put the square or you put the root doesn't really matter. Okay, now remember, for K alpha B is 1. This is the only value that you need to remember for K alpha. Now what is this K alpha, L beta, M gamma, etc.? It's very simple. Okay, let me tell you. See, when you have that energy level diagram, this is energy. Okay, this is, let's say, your K shell, this is your L shell, this is your M shell, this is your energy. Okay, when the photon is emitted, because of the transition from L to K, it's like your Balmer-Paschen Lyman series. Okay, so when the transition happens from L to K, this is called as K alpha. When the transition happens from here to here, then it is called as K beta, because it is coming to K. The photon is emitted because of the transition from something to K shell. So that is called as K, alpha, beta, gamma, etc. So from a much higher, it will be called K gamma, K delta, and so on and so forth. Similarly, when it comes from here till here, okay, so then it will be called as L alpha. Okay, that's how it is. The value of A is not needed, Kaveri, Kitat. It's not at all needed, the value of A. Okay, so don't even remember that value of A. Yes, correct. Okay, so if you want to find out the value of A, then I'll tell you what you need to do. Here is what you need to do. You need to use this formula. Where is it? Yeah, you need to use this formula. 1 by lambda is equal to R. Use this formula in a modified form. Z minus S, 1 minus N1 square minus 1 by N2 square. And instead of lambda, because C is equal to F lambda, so therefore 1 by lambda, you can see, is nothing but F by C. So instead of 1 by lambda, you put F by C. Alright, this was square over here. Okay, so this will become R Z minus S whole square, 1 minus N1 square minus 1 by N2 square. So when you take this C over here, you can find the value of, A. So this will be Z minus S whole square, and this will be this minus this. Now you can see this Z minus S, this S is also called as the screening constant. For K alpha, the screening constant is 1, and the other things outside, they become A. You can see that this is exactly in this form. So this is how it has to be found out, but nobody will ask you to find out the value of A. Ignore that. Okay, cool. Achha. So this is the graph of this particular equation. You can see, if you draw the graph of root of F versus Z, it comes out to be a straight line. And who modified the periodic table? Do you remember that? Who had arranged it based on atomic weight? And somebody came and told, no, you should not arrange it according to atomic weight. You should arrange it according to atomic number. Have you studied this in chemistry? Yes, the screening constant is basically, guys, you would have studied this in chemistry also. If you have this nucleus, positive charges, and you have these electrons, this electron will perceive slightly less charge because of that electron which is revolving before it. So the perceived charge is slightly less. That is the amount by which the perceived charge decreases is called as the screening constant. Yeah, I hope you remember it. Okay, so yes, who modified the periodic table? It was nothing but Moseley. Moseley's law. He told, yeah. So all the elements should be arranged in the atomic number, because this graph of atomic number versus this root of frequency comes out to be a straight line, not for atomic weight number. That's how it is. Yeah, very good. Finally, you guys remembered it. All right, last slide. Oh no, It's not the last slide. Yeah. That was the previous one was the last slide. Now let's get to problems, guys. I know you guys were waiting for it. After this we'll come to nuclear physics and then we'll go to semiconductors. Okay, let's start. Questions. According to Einstein's photoelectric equation, the graph between kinetic energy of photoelectrons and the frequency of incident radiation is interesting. The kinetic energy versus frequency will look like, is it A, is it B, is it C, or is it D? Interesting. Come on, my warriors, figure this out. A lot of you are saying D. Please say about de Broglie's wavelength topic. It has asked. Yes, NEET aspirant, I am going to do a lot of questions on de Broglie's wavelength also. We are going to do that. Okay, many of you are saying D. Very few people said C also. That's very interesting, but the correct answer is actually D. Why is it D? Use your photoelectric equation. HF is equal to phi plus kinetic energy. So kinetic energy will be HF minus phi. Now don't you see this is of the form Y is equal to mx plus c. Y is kinetic energy, x is frequency, m is h, which is positive, and the intercept is negative. So there is only one graph. This cannot be true because it passes through the origin. This also cannot be true because it is positive c. This has negative slope. Okay, this is the only one. When you extend it, you will see the intercept is negative. So that's the correct one. You can see intercept is negative. All right, next question coming up on your screen now. Okay, great. In a photoelectric effect experiment, the graph of stopping potential versus reciprocal of the wavelength is obtained as shown in the figure. As the intensity of the incident radiation is increased, then this line will shift towards, interesting question. Let's see what happens. Good morning, SSDN. Anaka saying D, Subarna saying D, Sanvi saying D, Technical Gamer, Kirti, Pankaj, all of you saying D. Konda and Rita also saying D. Interesting. Sure. Yana Siva, don't worry, bacha. These questions will be available to you as a PDF later on. Don't waste your time noting down the questions. You will get all these questions in PDF. I'll make sure that it comes on your Telegram channel of V Biotonic. Okay, don't worry. Just concentrate on solving these questions right now as if it's like your mock test. Okay, cool. Very good. Many of you are paying attention when I was explaining you the theory. See, reciprocal of wavelength is nothing but proportional to frequency. Remember, C is equal to F lambda. So C by lambda is nothing but F. So this indirectly can be replaced by, 1 by lambda. You can think of it to be proportional to frequency. Now we all know that stopping potential versus frequency, correct? The graph is a straight line. The intercept is minus phi by E, and the slope is, I think, h by E or something. Now if that is the case, what will happen if the intensity is changed? Guys, if you change the intensity, nothing will happen. I mean, the graph will not be even affected by it. Slope not dependent on intensity, phi not dependent on intensity, so it won't change. Intensity will only change the current in the circuit, not the slope or anything else. All right, cool. So that was the answer, option D. Going to the next question coming up on your screen. Very interesting question, AIPMT 2007. A 5-watt source emits monochromatic light of wavelength 5000 angstrom. When it is placed 0.5 meters away, it liberates photoelectrons from the photosensitive metallic surface. Now when the same source is moved away by total distance of 1 meter, then the number of photoelectrons liberated will be reduced by a factor of. Hitakshi was asking why not A for the previous question. Straight line shifts to the right. It will not shift because, Hitakshi, the reason is when you change the intensity, number of electrons will change. When the number of photons will increase or it will decrease. Okay, when you change the number of photons, number of electrons will increase or decrease, but each electron will still have the same energy. It's just that the quantity will increase. So stopping potential is only dependent on kinetic energy of a electron, not total electrons. So that's why it will not be affected. Okay, cool. So Let's see how many of you can get this. Very interesting question. Some of you are saying D, some of you are saying A. That's going to be interesting now. Nishchita saying B. Okay. Shivlakshmi mascot saying, sir, what a question. Okay, Anamika saying A. Interesting. So let's see what is happening. There is a source out here like this, and there is light which is falling on a metallic surface. So this is your surface, and what will happen is there will be electrons which will be ejected out. Okay, and these electrons will in fact make up the current whatever is there in that circuit. Okay, now we all know one thing. The current which is there, the current which is I, depends on number of electrons which are ejected per unit time. How many electrons are coming out of it? The number of electrons which come out of it obviously depend on the number of photons, incident. Okay, number of photons incident per unit time. Correct? More the electrons, that means more photons were colliding with the atoms and they were ejecting out. How will the photons increase? The number of photons will be completely dependent on the intensity. Intensity decides the number of photons which are coming out of a light source. Now think about it. What does intensity of the light source depend on? The intensity is inversely proportional to the square of the distance for a point source. Very, very important. So as you move away, the intensity decreases and it is inversely proportional to the square of the distance. Hence, the final logic will be, think this way, if my distance has changed from 0.5 meters to 1 meter, so that means my distance has doubled. So the distance square would have become 4 times. So intensity would have changed by 1 by 4 times. Everything will change by 1 by 4. So the current will change by a factor of 1 by 4. Understand this? The current will change by a factor of 1 by 4. That means it will be reduced. The question is not increased. The question is reduced by a factor of 4. So if the current earlier was 4 amperes, now it will become 1 ampere. It has reduced by 4 times. That's how it is. Yep. Clear? Okay. So you should know this formula. Alright. Very, very important. Let me also give you this one important thing. For a point source, remember, if you are at a distance r, the intensity is inversely proportional to r square. Okay. Similarly, if you have a line source, keep this in mind. Do you remember this? What is the intensity relationship? Well, it is not inversely proportional to r square, it is inversely proportional to r only. Okay, it's not inversely proportional to r square. Similarly, if your source is planar, so if it is a planar source, then keep this in mind. It does not depend on r. In fact, the intensity is constant for a planar source. Very, very important. So Gen Z bacha, in the previous question, what happened, or this question, when you increase the distance from 0.5 to 1, remember r has increased. If r has become twice, from 0.5 to 1 it is twice, so r square will become 4 times. If denominator becomes 4 times, intensity will fall by 4 times. The moment intensity falls, electrons will also fall, current will also fall by 4 times. That's how it is. Yep, very, very important. Great. Chalo, let's get going to the next one. The answer was D. Here's the next question coming up on your screen. When photons of energy h nu fall on an aluminum plate of work function this much, the photoelectrons of maximum kinetic energy K are ejected. If the frequency of the radiation is now doubled, the maximum kinetic energy of the ejected photoelectrons will be. Interesting. Why is the intensity constant, love? Because the wavefronts remain same in size no matter how far you go. That's an ideal scenario. In a real scenario, it will decrease, But if you have an ideal source which is planar, then the wavefront always remains of the same size. The energy does not spread. That's why the intensity remains constant. Okay, some of you are saying A, interesting. Sanjana saying B. Come on, let's see whether you guys are right, whether you guys are wrong. You should not take too much of time. These are very, very quick questions. There are two scenarios in this question. The first scenario deals with when the frequency is something, alright, h, or rather the energy is h nu. That time the maximum kinetic energy is k. Start with your photoelectric equation. H nu will be work function plus kinetic energy. Second time what is happening is, when the frequency is doubled, that means this will become h into 2 nu. Work function won't change, the kinetic energy will be something else. All you need to do is subtract them, just subtract them. Okay, so h nu minus h2 nu, 5 minus 5, 0, so plus k minus k1. Take k1 over here. H nu minus 2h nu is minus h nu is equal to k as it is. So k1 will be k plus h nu, which is option A. That's it. That's the answer. Straightforward, simple equations. Two scenarios. First time frequency was nu, kinetic was k. Frequency has been doubled, energy will double. Kinetic energy won't double. It will just become something else because there is a constant which is phi over here. Just eliminate phi because you don't need it and you will get the answer. Straightforward pretty much. Alright, excellent. Then it is not C, bacha. Love, it's not C. Okay, be careful. Okay, it was option A, correct. AIPMT 2006. Now AIPMT 2005 question. The work function for a metal A, B and C are 1.92, 2 and 5 electron volt. According to Einstein's equation, the metals which will emit photoelectrons for a radiation of wavelength 4100 Armstrong are is how much? Come on, think about it. Think carefully. How would you use Einstein's equation and decide which of these metals will emit photoelectrons or they will not emit photoelectrons? Think about it. Okay. Interesting. And there we go. B, A. People are confused clearly between B and A. Interesting. Okay. So first of all, think what is the energy of the light which is incident. The energy which is incident will be hc by lambda. You can also use this relationship 12400. Okay, this is in electron volt and this is 4100. Again, this should be in Armstrong. So when you do the math, okay, just check this out. This 0 will get cancelled out. Yep, I think, yeah. So you should get this as 3. Yep, you should get this as 3. Oh, yep. Almost 3 point something. Okay, just almost 3 point something. Now my point is that, yeah, almost like 3 electron volt. Okay. Now my point is, if the energy which is incident is itself 3 electron volt and the work function, look at this work functions 1.92, 2 and 5. This 5 cannot emit the photoelectron because 3 is less than 5 electron volt, but it is more than 1.92 and it is also more than 2.0 electron volt. So that means for these two you will see the photoelectric effect will occur. For this one over here you will see photoelectric effect will not occur. So 1.92 and 2, which are those metals? A and B. So only for A and B it will occur, not for all of them. A lot of you are confused, they thought it was only A. The answer is A and B both. Yes. C, it will not occur because it has more work function than what it can, emit. Okay. Great. So answer is B, which is A and B. Excellent. Let's get going to the next one coming up on your screen. Based on de Broglie's wavelength. Yes, Gen C, it is 12400 is a constant which you should remember. So, oh, some of you are confused, sir, where did that 12400 come from? See, whenever you have hc by lambda, right? Instead of substituting c as 3 into 10 to the power 8, h as 6.62 into 10 to the power minus 34, and then converting it into electron volt, converting lambda into meters from Armstrong, you can also write this as, 12400 divided by lambda. Make sure this lambda is in Armstrong and this entire answer will be in electron volt finally. Okay, keep this in mind. This is the shortcut. You can avoid some calculations using this constant. Is that clear? Very good. Thank you, Angel Rose. Okay, next question coming up on your screen now. A proton, a neutron and an electron and an alpha particle have same energy, then compare their de Broglie wavelengths. It's going to be very interesting. Sahal PM saying B. Yes, Sushmita, it is not. Okay, come on, my warriors. Nitya, if you want all the lessons, please check out the crash course. Understand my time is limited, so that's why I'm coming for all the important chapters, high weightage, high scoring chapters, so that you get that confidence. But if you want all the chapters, I wish I could do it, bacha. That's why I recommend you guys join the crash course. There is a link in the description box. It has all the sessions with test series, with mock tests, and also personalized attention where you can get all your doubts also cleared. You can send as many doubts as possible. Okay, a lot of you are saying C and B, confused. Some of you are also saying D. Okay, clearly there is a confusion. Now, de Broglie wavelength depends on the momentum. So it is h by p. The problem is there is no momentum involved over here. The energy is same. Now, is energy and momentum related? Yes, it is. How? Observe. Kinetic energy, okay, kinetic energy, Ke, I can say is nothing but, or I can just put K. K is nothing but half mv square, or you can also write this as p square by 2m. You might have heard about this formula also. You just substitute p as mv, yeah? It's simple. M square v square. One of the m will get cancelled. You will still get half mv square. It's one and the same thing. Now just rearrange this. So p square will become 2mk. So therefore p will become root of 2mk. Correct? Now substitute that over here. This is very, very important. This is a standard formula. So lambda will become h by root of 2mk. Now it becomes easy for me to compare. How? Because it's clearly mentioned in the question that all the energies are same. Look at that, the energies are same. H is also same. Only thing which is different is the mass. So observe, for the mass, what you can do. For mass, who is the highest mass among all of these particles? Proton, neutron, electron and alpha. Mass wise, alpha is the highest, then comes proton, which is roughly the same as neutron, and then comes electron. Now you can see mass is below, lambda is on the top. So lambda is on the top, so that means alpha will have the least wavelength, then proton and neutron almost the same, and then comes electron. So I think that should be option B, I guess. Just check this out. Yep, makes sense, everyone? Clear? Alpha has the highest mass because it's made up of 2 protons, 2 neutrons. Yep, proton and neutron roughly the same. So that's why equal to. Electron has the least mass. So inversely related. Lambda is on the top, mass is below. So that's how you need to solve the question. So you have learned a lot of things. You have seen how energy and momentum are related, and how you can relate momentum and wavelength, and how you can also relate wavelength and energy. Very, very interesting relationship. Correct answer was B. Going to the next one. Let's see how many of you can do this. Beautiful, amazing question. Yep. Come on. Think about it. A particle is dropped from some height. The de Broglie wavelength of the particle as a function of the height is proportional to. Come on, my warriors, figure this out. Yes, Gautam Bacha, you will get the PDF also. Yep. Just like last time, you will get the PDF. Okay, don't worry. Come on, show some josh. And by the way, if you have forgotten to smash the like button, please do that right now. If you are enjoying the session, yeah, please do that. Go hit the like button. And if you are new to this channel, please hit the subscribe button right away. People confused between B and D. Deepa also saying A. Very, very interesting. People are confused clearly. Somebody is also saying C. Nivedita, I think. All right. Somebody said already light. Very good. Mascot. Okay. So B and D confused. All right. So a particle is dropped from some height. It will gain some velocity. What will be that velocity? Okay. How do I find that out? It's very simple. Use kinematic equation. So V square is U square plus 2 into acceleration into height by which it falls, because it starts from rest. Okay. So therefore V will be root of 2gh. Now comes momentum and wavelength. Wavelength is h by p, that is your de Broglie wavelength. So what is the momentum? It is mass into velocity. What is the velocity? Root of 2gh. Now this is the catch. You know, so many people made a mistake here. You know what is the mistake they made? They cancelled this h and this h. Guys, this h and that h are different. Nitesh, which part are you confused, bacha? This is just velocity. Use kinematic equation. The moment you get velocity, every matter has a matter wave associated with it. That is called as a matter wave, and the wavelength of that is the de Broglie's wavelength. Lot of people got confused. H and H cancel. Guys, do not do that. That's why what you can do, you can write this as capital H. This is height. This is capital H. Height. So this will also become capital H. Now you can see it does not get cancelled. Therefore, lambda will be h by m and root 2g. If you take h on the top, it will become h raised to minus half, because the root is half power, and you take it on the top, it becomes negative power. So h raised to minus half, and that's option D. Now you got it, guys? Yep, clear? Oh my god. You have used potential energy formula, is that right? Yes, bacha, you can also use potential energy formula. Even if you write mgh is equal to half mv square, you will still get V is root of 2gh. It's one and the same thing. There's just two ways of approaching the same problem. It's up to you. Okay, clear. Excellent. All right. Oh my god. Mr. Faisal OP saying all the questions are going above head. Catch it. Please catch it. Or jump, bacha. Please jump. Probably you will be able to understand. Okay, and the way you can jump is start from beginning. I hope you have revised the theory, and I hope you already know something at least about atomic structure. If you are seeing thing for the first time and you are expecting that I'm going to create a miracle, no, that's not what's going to happen, guys. Okay, it's difficult to do that. Okay, cool. How many sessions I completed on this channel? Hema, I did one strategy session, I completed one ray optics session, and now I'm doing this session, and probably next week I will do one more session, and then I'll do some mock tests. Okay, so you have to leave it in the comments after the video ends what kind of sessions you want. Based on that, I will conduct more sessions. Okay, thank you. Cool. All right, there we go. Next question coming up on your screen, and here it is. You know theory and formula but unable to substitute it on problem. Master Faisal, that means you lack practice. Whenever students say, sir, I'm not able to solve problems, sir, I don't know when to use formulas, there's only one medicine for that. So you guys are going to become doctor. Patients are going to come with these symptoms. This is my symptom. मेरे पेट में दर्द है, हजम नहीं हो रहा कुछ, गले के अंदर कुछ नहीं उतर रहा. So you will get to know the symptoms, and accordingly you will diagnose and prescribe. So I am the doctor now. I know what it is. The problem is you have not done enough practice. So you need to just do that. You need to solve lots and lots of variety. Just doing the same problem again and again, no use. You need to solve variety of questions. Start with the easy questions, substitution based questions. Maybe you have picked up the wrong book. Maybe you have not got the correct set of assignments or questions. That's where the problem is. So just do that, probably it will work. Okay, just check my strategy session. I have mentioned about it. Okay, chalo, lot of you are saying D. Interesting. Yeah, most of you are saying D. Okay, so the correct answer is actually D, and I'll tell you why. See, what has happened, the transition from 4 to 3, okay, transition from 4 to 3, where is 4? 4 to 3 is over here. What has that emitted? That has emitted ultraviolet radiation. Guys, out of ultraviolet and infrared, who has more wavelength, or who has, check this out, out of ultraviolet and infrared, alright, who has more wavelength or less wavelength? Think about it. Ultraviolet is short wavelength, infrared is large wavelength. So wavelength wise, ultraviolet is less. Achha. So energy wise, ultraviolet will be more than infrared. That means the gap should be less for infrared, think about it, than the gap for ultraviolet. The ultraviolet gap is this much, the infrared energy gap, the energy is less for infrared. So think about it, for infrared, which transition will give you lesser gap? 2 to 1? Definitely not, it's a big gap. 3 to 2? Definitely not. Remember, 3 to 2 is bigger than 4 to 3. Did I not just mention some time back, these spacings are not equal. Every successive spacing as you go on the top keeps on reducing. So that's something which you should keep in mind. 4 to 2 obviously is big. There's only one thing which is less, and that is 5 to 4. So 5 to 4, which is over here, this will give rise to infrared radiation. Alright. Yes, correcto. That's how you need to solve this question, and that's how you get the answer. You should know who has more wavelength, who has less wavelength, and you should know that energy is inversely proportional to the wavelength. Next question coming up on your screen now. Kaveri, we started at 9 and it is 10:10. Very interesting, and the class doesn't look like it will end very soon. Okay, I hope you guys are fully energized, and I hope you guys are fully prepared for this long session, because I'm warning you in advance, it's not going to end before 11:30. Okay, as an electron makes transition from excited to the ground state of a hydrogen-like atom or ion, then what will happen to the kinetic potential and the total energy? Yes, Nichal Vacha, you can watch for mains, no problem. Come on, think. What will happen when an electron makes transition from excited to the ground state? What will happen to the kinetic potential and the total energy? Okay, let's see. Some of you are saying C, some of you are saying, everybody, Srujal saying A, Rita also saying A, Pujita saying C, Shafla saying A, Rahul, Deepa saying C, Riya also saying C. So the formula that you need to use is, see, energy is inversely proportional to -1 by n square. This is the total energy. I had also told you about kinetic energy and potential energy, etc. Remember, kinetic energy, alright, is just the negative of energy. Kinetic energy is negative of energy, so it is indirectly proportional to 1 by n square. Similarly, think about this potential energy, okay, U. Potential energy is nothing but twice of total energy, okay, so that means it will be inversely proportional to again -1 by n square. Now, going by this logic, if it goes from excited to the ground state, this clearly means n has decreased. It has decreased. Excited to the ground. If n decreases, if this n number decreases, this whole ratio will increase. That means it will become more negative. Is it not going to be true? It's going to be, this E will become more negative. I hope this is clear. If it becomes more negative, that means the energy has increased or decreased. Obviously the energy has decreased. It becomes more negative from -2, -3, -4, -5. It is decreasing. So the total energy has definitely decreased. If total energy decreases, you can see directly from here, you don't even need to do anything here. This is not even needed, actually speaking. Okay, this is not even needed. Okay, just think about it. If total energy decreases, that means potential energy also decreases. Make sense? Great. If energy decreases, the negative of energy will increase. That means kinetic energy will also increase. So only kinetic energy will increase, but potential and total energy will decrease. That's option C. That's it. That's it. Very good, Sakshi, Dad Gaming, Yalini, Sakshi, Rita, Alia, Subarna. Very good. Excellent. Proud of you, my warriors. Going to the next question coming up on your screen. Option C is correct. Here it is. Why does hydrogen atom not emit X-rays? Why is it that hydrogen not emit X-rays? Is it because the energy levels are too close to each other? Is it because the energy levels are too apart from each other? Is it because it is too small in size? Or is it because it has a single electron? Interesting question. Come on, what is the answer? Yana, Siva, Madhav Reddy, the Telegram channel link will be there in the description box below. Prithviraj, loving these questions, glad. Some of you are saying D, some of you are saying okay, B also. Guys, most of you are wrong. If this question came in NEET, trust me, everybody would get a 0 mark or negative mark. So the correct answer is A. See, remember X-rays, it's clearly mentioned X-rays. X-rays have lambda, which is very, very small. Lambda is very, very small. If lambda is very, very small, that means, understand, the energies which are involved, all right, the energy differences which are involved is very, very high. And this cannot happen in hydrogen atom. If you have a hydrogen atom, even if the other shells are empty, even if the electron jumps and comes back, these wavelengths which are emitted, they are in visible spectrum or infrared or ultraviolet. You would have studied this in Lyman-Balmer Paschen series. They are in that spectrum. Only when Z increases, that's the atomic number, when you have a big atomic number, big Z, and then what happens, these energies become very large, and then when the transition happens from higher to lower orbit, then you will see X-rays coming out. That's what happens. And if you remember, there is a formula also, 1 by lambda is equal to RZ square. So think about it. This was the formula. So if Z is more, lambda is less. If Z is more, lambda is less. So that's why for hydrogen, it does not emit X-rays, because Z atomic number is very less. Yep. Okay. So that's why it's very important that you attend all these questions. Next question. An X-ray tube is operated at 40 kilovolt. Find the shortest wavelength of the continuous X-ray spectrum. Let's see how many of you get it. Come on, come on, come on, come on. Yes, Nityashri, correct. It's not only -1, it is -5 if you compare it with what you could have got and what you are getting. Very true, Nityashri. Looks like you have attended my session on strategy for NEET to get more than 150 plus in physics. Okay. Harsha, I did not say more electrons are needed. I said more Z is needed. That means more amount of protons in the nucleus are needed, because Z decides energy levels, and more the energy levels, higher the energy levels, then greater are the chances for you to emit the X-rays, which are highly energetic in nature. That's all. It's not about whether it has single electron or 2 electrons. You should have those energy levels. All right. Oh, Saujanya, oh, this is your father's account. Okay, fine, fine, welcome. Okay, D and A, people are confused again. All right. So we know the formula EV is Hc by lambda. Rearrange. You're going to get lambda. This is for continuous. Remember, for continuous, you had that X-ray spectrum. It goes like this. This is your lambda, which is minimum. This is the cutoff. And it only depends on, the voltage which you have applied. So lambda will be Hc. Okay, Hc by EV. Interesting. Can I do something over here? I feel I can do something. Look at this. How do you solve this problem, guys? First of all, Hc, can I write it as 12400? There is an E over there. Remember, it always comes in electron volt. Remember, it always comes in electron volt. Hc 12400. I just told you some time back. And EV. What is voltage? Voltage is 40 kilovolt. So 40 into 10 to the power 3 volt. But there is also E over here and V over here. Do you guys understood what I just did? This E is the same E over here. This 40 kilovolt, this is K. This is kilo. This K stands for 10 to the power 3. So this has become EV. And I just gave you the shortcut. Hc is 12400 electron volt and all of that. So from this, you can see that, you're going to see 124 divided by 2 zeros are going to go. All right. And I will be left with 40 into 10 to the power 1. Now that's basically nothing but 400. So you can see this 124, you can divide by 4 into 10 to the power minus 2. You can just write it like this, correct? So that means it's going to be roughly 0.31 Armstrong, guys. Remember, all these answers will be in Armstrong. This 12400 was for Armstrong, correct? So this is an easy way for solving the problem, where you don't have to substitute the value of H or C. You just can substitute the value of Hc as 12400 electron volt, and answer will always be in Armstrong. Understood? Clear? Great, great. Let's get going. It's approximately 0.31. Excellent. Very good, Sakshi. Very good, Yalini. Excellent, Prithviraj. Shreya Soni, is HC Verma really required for NEET or any other module will do? Shreya, if you want to crack NEET exam with good marks, then you will need HC Verma. But if you want average marks, then there are a lot of other books also available. So I just aim for the best. So that's why I tell you HC Verma. But do not solve exercise questions. Just solve conceptual questions like objectives, short answers, theory, and solve examples. Nothing more. Okay? That's what you need for getting the concepts. Because there is no other book better than HC Verma for theories, definition, correctness, and accuracy, and the variety of questions which you need for medium to average level. Alright, wavelength of K alpha for an element with Z is equal to 31 is lambda. What is the wavelength of the element when Z is 21? Interesting. It's based on X-rays. Okay, come on. Come on, my warriors, figure this out. The wavelength of K alpha for an element, Moseley's law, that's your hint. Josephine, NCERT is barely enough. It's enough, but it will not give you very good marks. Let me also tell you that. You need it. Only if you do HC Verma, you will not get full marks. Only if you do NCERT, you will not get full marks. The combination of NCERT and HC Verma, that's when you get full marks. Okay, let's see how many of you got this. Based on your Moseley's law. Okay, and let's see, guys, what we need to do. So Moseley's law was all about root of frequency is A into Z minus B. So how about this? Since we all know C is equal to F lambda, so how about substituting F is equal to C by lambda, correct? So just do that. So you will see this will be nothing but C by lambda is equal to A into Z minus B. Now what I'm going to do is, because there are two Z's and there are two lambdas, let me just divide both of them. Because I can indirectly see root of lambda is inversely proportional to Z minus B over here. Forget the C and forget the A. Inversely proportional between root lambda and Z minus B. That means I can write this as lambda 1 or lambda 2 divided by original lambda will be nothing but, for the first wavelength Z was 31, so Z should come on the top, so that is 31 minus 1. For the second wavelength the Z should come below, and that is 21 minus 1. 31 minus 1 is 30 and 21 minus 1 is 20. 0 0 goes, 3 by 2, so lambda 2 by lambda, square both sides, so 9 by 4 I suppose. That means lambda 2, take the lambda on the top, that will be nothing but 9 lambda by 4. Is it there? Yes. Oops, there is 4 lambda by 9. Did we just make a mistake or what? Just hold on. I think there was a lambda missing over here. I think that printing mistake is there over here. Yep. B is equal to 1. Oh, I think you were missing when I was talking about the theory for X-rays. I told you guys, for K alpha, remember this value B is 1. You should know this value. That's the only value which you should know. Nobody will ask you for K beta, what is it? If it is K beta or K gamma or L alpha or L gamma or anything else, they will give this value. So remember this. This is something which you should know. So B is 1. Okay? Yeah, that's a standard. Can we complete a book in 20 days? No, not possible, bacha. Okay, yes. Clear? Now I think it is clear. All right. So this lambda was there. I think there was a printing mistake. That lambda is not there over there. Okay, great. Mrunal, for quiz, there is a test series which is running, bacha. now is not the right time where we conduct Menti quizzes because it will take a lot more time. Instead, utilize this time. There is very limited time. I know Menti quizzes are fun. Your brain will be attracted towards fun elements. But now it's not the time for fun. Now it's the time for serious preparation. So I would humbly request you to please join the test series where you get more and more of practice. The link is there again in the description box for joining the test series and even the crash course. Okay. Then Monkey Sunny, what can we do it? What do you want to do? Monkey Sunny? What is this name? Monkey Sunny. Interesting. Dhoop wala bandar. Interesting. Okay. NCERT PYQ enough for 120 marks? No. Just PYQ is not enough. Mohammed. Okay. Nucleus. Yes, Nivedita. 1 minute water break. In the kitchen, right, there is a Kaju Katli there. I really want to go there and get that Kaju Katli, but then I have to remove this mic and all of that, plus a lot of disturbance. So I'm like, okay, I'm controlling it, okay, only for you guys. You better make it worth, yeah? Please hit the like button, at least for that. I'm sacrificing Kaju Katli. I'm not going out of this room. In yesterday's class on VNQs, I ate that Kaju Katli. There's still 2 more pieces. I just hope nobody eats it before I finish my class. Just hope. Okay, chalo. No love, too much of trouble. Prithviraj loves it. Yeah. So guys, it will be fun, right? When you crack the NEET examination and you distribute sweets and party. And guys, promise one thing. Once you clear NEET and get amazing marks and you get a medical college admission, whatever, that pamphlet or whatever, your certificate or admission card, you should come down to Bangalore, you should come down to the Vedantu office and we should all celebrate together. Yeah, trust me, I'm a foodie and I love eating and we will all eat together. Like, I don't know, Bangalore has a lot of nice places to eat and I hope there will be no lockdown then. So we are going to have fun and promise me that we are going to do that, okay? Yeah, that will be fun, trust me. You can meet all your teachers, all the teachers that you have been learning from at Vedantu, be it Vani ma'am, but Vani ma'am is right now in probably somewhere in Chandigarh. So probably you should tell her, yeah, come down to Bangalore, then you should ask Mohit sir and all the teachers that you are taking guidance from or taking the lectures from, to meet over here and trust me, it's going to be amazing. All right, let's start with nucleus. क्या बोल रहा nucleus? अच्छा, तो ये है nucleus. Okay, first thing, the radius of the nucleus. If you think of this like a sphere, the radius of a nucleus is given by this formula, R0, constant, a raised to 1 by 3. This constant is 1.1 10 to the power minus 15. This is also femto. This is femtometers. Like you have pico. Pico is 10 to the power minus 12. Nano is 10 to the power minus 9. Okay, micro is 10 to the power minus 6. Femto is 10 to the power minus 15. So this is 1.1 femto. That's extremely small. The radius is dependent on A. What is A? A is nothing but, your atomic number of particles inside that. But over here, this will be Z plus N. The number of protons plus the number of neutrons. Great. Now, protons do not like each other. Neutrons are neutral particles. So to make them stay together in that nucleus, you need some kind of counseling. You need them. The conversation will be something like this. Like a proton will be like, I don't like you. Other proton will be like, oh, same bro, I don't like you either. So, to bring them together, you need something which unites them. Much more, which is more divisive than whatever, agendas they have. They don't like each other. So, neutron comes there and you're like, okay, you guys calm down, cool, and there are some nuclear forces which are involved, and those nuclear forces are much more stronger than those electrostatic forces. It's like suddenly these protons discover, अरे तू तो मेरा चाचा का मामा का बेटा है, वो खून का रिश्ता है, चलो साथ में रहेंगे, ऐश करेंगे. So that's how they stay together in this nucleus. because they have some stronger bonding beyond the electrostatic forces, and that is nuclear forces. Now, those nuclear forces act between protons, protons, neutron, 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 proton, and all of that. You don't have to study too much about those forces, but you should know it is there. Now, you might think that, okay, having too much of neutrons is good, but no, because that neutron acts like a binder between those protons. But the moment there are more neutrons in the picture, then in fact the opposite happens. It's like neutron is like the mediator. This proton does not like this proton. Neutron is like, tu idhar, wait a minute, I will bind you together. But if too many mediators come, bahut sare log aa gaye, then these protons are like, what the hell? Just for two of us, these many people now have to form bonds with so many people. That proton will be like, to hell with you, man. I don't want so many people. I'll go away. So it will become very unstable then. So that's what will happen. Okay. So that's how it is. Now, having said that, the moment a nucleus explodes into two smaller nuclei, two daughter nuclei, that is called as fission. And when two nuclei combine together, that's called as fusion. The moment that happens, there is always some mass which is lost or gained, and that mass can be converted into energy by the famous Einstein's equation, which is E is equal to delta m c square. Delta m refers to the mass defect, mass which is created or destroyed. This is the energy which is equivalent. This is the energy which is again created or destroyed. So if mass is created, energy is destroyed. If mass is destroyed, energy is created. The total amount of mass energy equivalent in this universe remains constant or conserved. Similarly, this formula can also be rewritten in a very different way, because it is more useful to write it in a different unit, especially at nuclear level, and that is electron volt. So if you write this mass defect in atomic mass unit, and see, if you substitute it as 3 into 10 to the power 8 meters per second and then convert it into electron volt, the final answer will come like this: delta m into 931 MeV. So this is very, very important. Okay, this is the equation which I just gave you, but also remember this can be written down as delta m into 931 mega electron volt. So you don't have to break your head on substituting the value of C or converting it into an electron volt and converting it into atomic mass unit. So remember this value 931. All right, great. Now you don't really have to remember this formulas as such. You don't have to remember, but instead I will give you a beautiful explanation, and remember this always. Imagine there are two protons and there are two neutrons. There are four particles, two protons here far away, two neutrons also far away. Now let's say they combine together and they form let's say a helium nucleus. So what is this now? This has now become nothing but, a helium nucleus. Tell me whose weight will be more if I weigh these four particles together, and if I weigh this nucleus, neglect the electron, if I weigh only the nucleus, whose weight will be more, independently or together, or both will be same? Come on, my warriors. I'm coming to that. I'm explaining mass defect, Glorious Mary. I'm coming to that. My God, what kind of crazy names you have. Glorious Mary. I should also have my name, something like that. Glorious Shreyas. I should put a lot of adjectives. Fierceful, glorious, bright Shreyas. I don't know, something crazy. Okay, together depends. Okay, so guys, the answer is all, well. It's not same. I'll tell you what, it will be more when they are independent. This mass, trust me on this, if you can consider this mass is slightly more. And if you only look at this mass over here, this mass is slightly less. You'll be like, sir, why? What just happened? I thought 1, 2, 3, 4. 1, 2, 3, 4. Same particle, same proton, same neutron. Remember, the mass of a proton or a neutron inside the nucleus is always less. You'll be like, sir, what has exactly happened? See, these protons don't like each other. These neutrons have binded them together via nuclear forces. So it has become more stable. Correct? This is right now stable as compared to this. It has formed a bond. And have you studied this in chemistry? Whenever things form a bond, what happens? Energy is released or energy is absorbed. Come on, let me know in the chat box. What happens when a bond is formed between two molecules, two atoms? What happens? Energy is released or absorbed. Similarly, over here, a nuclear bond is formed between the protons, neutrons. Will energy be released or will it be absorbed? Obviously, it will be released. So obviously, you should have some energy over here. Now, this is the energy which is created, energy which is released, which is created. Where will this come from? This will come from the mass which is destroyed. So this will come from the destroyed mass. Keep this in mind. So hence, the mass inside the nucleus will be slightly less. So mass will be lost. So this mass is less. Keep this in mind. Okay. So keep this in mind. Any kind of nucleus, when the protons are outside, when they form a bond, there will be some defect that is called as the mass defect, and that will be translated into energy. This is called as the binding energy. This is called as the binding energy. And if you divide binding energy with atomic number or mass number, what is this number called? This is called as binding energy per nucleon. What is this called? This is called as binding energy because there are many nucleons per nucleon. Keep this in mind. Very, very interesting. Okay, very good. Now, all of this, etc., you don't need to know too much. I mean, it's fine. I mean, you don't need to know what is Q value. It's final minus initial again. So, anytime there is again a nuclear fission or fusion reaction, understand there will be some mass defect. And the moment you know mass defect, just use this formula. If they ask you Q value, if they ask you binding energy, don't break your head over it. Just find mass defect. That's the whole aim. That's all you need to do. Radioactivity. Yes, radioactivity. Coming to that, whenever you have a radioactive material, it decays exponentially. Rate of decay, this is decay rate, which is also called as activity. Activity is lambda into n. This is the number of radioactive nuclei, okay, nuclei left in that particular material. And when you integrate this, you will get this formula. N is n naught e to the power minus lambda t, standard. Half-life, the time after which the material becomes exactly half, that is 0.693 by lambda, which is ln2 log 2 to the base e by lambda. Average life, the average time for which a molecule or an element stays alive is the average life. Don't confuse it with half-life. Half-life is when the material becomes half its original value. Average life is the average time for which a material stays alive before it decays or disintegrates into the daughter nuclei. That's 1 by lambda. Now, this one you don't have to remember separately, but it is very obvious. After one half-life, it will become 1 by n, 1 by 2 of original one. After 2 half-lives, half of half is 1/4. After 3 half-lives, half of half, 1/8. After any n half-lives, it will become 1 by 2 raised to n. So that's the population after n half-lives. As simple as that. What is this lambda? This is called as your decay constant. This is called as your decay constant. Oh, by the way, does this remind you of your first order kinetic reactions? Think about it. Does this remind you of first order kinetic reactions where the rate of reaction continuously changes and all the formulas are very, very much similar? Yep, very good. Glad you guys remember. So this is the graph. Initially there will be a lot of material and slowly it decays. It's called as an exponential decay because of this equation. the material at any time is initial number of nuclei e to the power minus lambda t. So when you substitute different values of time, the values of n that you get are exponentially decreasing or decaying. That's why you get that term. Okay. Standard reactions which you should know. Yep. Standard reactions which you should know. Alpha decay. And alpha decay is when a parent nuclei, a radioactive nuclei, emits the alpha particle, and alpha particle has atomic mass number as 4, atomic number as 2. So in the daughter nuclei, you will see the atomic number will be reduced by 2, atomic mass number will be reduced by 4. Remember, the things on the top should be conserved and the things at the bottom should also be conserved. So you can see on the top, you should see on the left hand side it is A, RHS also should be A minus 4 plus 4 is A only. Same thing over here, Z minus 2 and 2. If you add them, they should be equal on both sides. Okay, standard. So parent nuclei, daughter nuclei, alpha particle, it's nothing but doubly ionized helium nucleus, nothing else. Beta negative decay. Negative beta, usually when I say beta decay, it's also called as beta negative decay, which is nothing but an electron. So when that happens, the daughter nuclei has one extra atomic number because that beta particle will have -1 charge. So there will be one proton which is created. Keep this in mind. So in this, a neutron has converted into a proton and electron. So what has happened? A neutron has converted into a proton plus electron. This is something which you should know. Alright. Similarly, there is also something called as a beta plus decay. Have you heard about that? In a beta plus decay, there is a positron which is emitted. This equation looks very similar except for the fact that instead of beta with -1 you put +1. So over here you will have Z minus 1. This is called as a plus beta decay. Keep this in mind. Okay, this is positron. It's like the Judwa bhai of an electron. Gamma emission. Gamma emission, what happens is the parent nuclei is right now in its excited state. It's highly excited state, and when it goes to its ground state, there is no change in atomic number or atomic mass number. The only thing which is emitted is a gamma particle, which is nothing but electromagnetic waves. These were actual particles, protons, neutrons, etc. This is a photon, please understand. So photon does not have charge nor does it have mass. So 0, 0. So that's why you have shown it as a electromagnetic wave. Clear, everyone? Very good. Yes, it's the antiparticle. Yes, correct. Great. So remember this, very, very important. Let's start with the questions. I know you guys are waiting for it. Okay. The radius of germanium nuclei is measured to be twice the radius of beryllium 94. The number of nucleus in GE are, come on, very simple. Shruti, I'm coming to that question. Neutrino is with electron or positron? Very important question. I'm going to come to that in a bit. There's a question on that. Okay, just wait for it. Okay, come on. Sushil saying A. Come on, my warriors, figure this out. What is the answer? Antipositron. Antipositron is called as electron. Okay, as simple as that. Electron and positron are antiparticles of each other. Okay, let's do this. I think this is based on the radius of the nuclei, nothing else. So the radius is directly proportional to the cube root of the atomic mass number. So the radius of germanium, okay. So radius of germanium upon, okay, radius of germanium upon radius of B is equal to cube root of A of germanium, which I do not know, okay, upon A of B, that is nothing but 9. Do not take 4, it's 9. Yeah, be careful. So this is 2. So 2 is equal to cube root of A by 9. So take cube on both the sides, so you'll get 8 is equal to A by 9. So therefore A will be equal to 9 into 8, which is 72. Yes, option should be A. Yep, very good Shana, very good Zahir. Hello, hi real fighters, that's wrong. Yes, Pagla Reshma Priyadarshini. What name, man? Reminds me of Yamla Pagla Divana, that movie by all the Devs. Epic movie. You should watch it. It's too much fun. Okay. So Sakshi says yes. Yep. Hello Nidhi. Welcome aboard. Okay. Next question coming up on your screen now. The mass of a proton is 1.0073 U and that of a neutron is this much. Binding energy has been asked. Let's see how many of you can get this. Very straightforward question. So, for finding out the binding energy, what you need to do of helium, okay. So, the binding energy will be nothing but, delta M into 931 mega electron volt. Okay. What is the mass defect? Now, we all know that the protons and neutrons separately have more mass as compared to the helium nucleus. Okay. So, what will be the mass of those 4 particles inside the helium nucleus separately? So, there are 2 protons. Each proton has a mass of how much? Yeah, mass of the proton is 1.0073. Okay. Plus, there are 2 neutrons, each having mass of 1.0087. Okay. This whole thing minus, do not forget, you have to find a defect. So this is the total mass of the 4 particles separately. So these were 2 protons, 2 neutrons, and this is helium nucleus. So what is the mass of the helium nucleus? That's given to be 4.0015 into 931 mega electron volt. Okay, so you just need to do this now. So 6, 14, yep. So 0, 2 point, and this will be nothing but 14, 16, 17, yep. So 0, 2.014. Just check this out. Yeah, correct. Very good. Yep, and somebody has already started posting the answer, 4.0015, and this whole thing into 931. So just do this. So this will become 4 plus 6, this thing. So this should become 320. Just check this out, 320. Yep, minus 4.0015 into 931, and just subtract them. So 4.0320 minus 4.015, correct? So it should be 0.0305. Yep, that's correct, into 931. Now you can do one thing, you can write it as 3.05 into 9.31. I just shifted the decimals. Okay. Yep. So yeah, I've just shifted the decimals. That's fine. Correct. Now, the reason why I've done this, I'll tell you. 9 3s are 27. Correct. 9 3s are 27. This is slightly more than 3. This is slightly more than 9. So the answer will be definitely more than 27. So slightly more than 27 is this one. So you don't have to even calculate this. Okay. Done. Clear. Very good. Most of you have answered it. Okay. Excellent. All right, fine, it's a surname, great, no problems. Next question coming up on your screen now. The sample of a radioactive element containing this many active nuclei, half-life of the element is 10 days, then the number of decayed nuclei after 30 days is straightforward. Come on, let's see. How many of you can do this? Nivedita, you should know how to calculate, bacha. You should know. Little bit at least. Come on. You cannot say, sir, I'm going to be doctor, I don't need calculations at all. Come on, you're going to need calculations in life for so many things. Okay, so this element has this many nuclei after half-life of, if the half-life is 10 days, then after 30 days what will happen? So initially it was 4 into 10 to the power 16. In 10 days, what will happen, guys? This will exactly become half, so it will become 2 into 10 to the power, 16. In more 10 days, so that is 20 days in total. How many will be left? 1 into 10 to the power 16. In more 10 days, that is totally 30 days, how many will be left? 0.5 into 10 to the power 16 will be left. The question is decayed. Many of you made a mistake. Rita, it is not A, be careful. So how many have decayed? So all you need to check, this was initial, this was what was left. So it will be 4 minus 0.5, which is 3.5 bacha. So hence the answer will be C. Correcto. Yep. Chetan, it's not A bacha, it's C. Be careful. Yes. So don't make these kind of mistakes. That's why I'm doing these questions. Read the questions carefully. You would know the answer. You would know how to do it. At the end of the day, outside the examination hall, you will be like, oh, I knew how to do it. I made a silly mistake. That's how silly mistakes are done. Next question. Somebody was asking about neutrino and all of that. It's coming now. A nuclear reaction given by this represents which kind of decay? Come on, guys. This is a simple one. Yep. Be careful. This is a simple one. What kind of reaction does it show? Is it beta minus? Is it a beta decay? Is it a gamma decay? Is it a fusion? Is it a fission? Come on, my warriors, figure this out. A for sure. Thank God. Look at this. Suddenly when I put simple questions, the chat box gets flooded. Very good. You should be able to do this. Yes, it's a beta decay. This is an electron. Electron is a beta. Beta decay. Okay. Beta chhod ke chala gaya. Okay. Next question. Let's see. For the given reaction, the particle X is neutron, antineutrino, neutrino, proton. Very interesting question. Carbon got disintegrated into beta and boron, and you have this X particle. What is this X? Is it neutron? Is it antineutrino? Or is it neutrino? Or is it something else? Come on, my warriors. Okay. Let's see. Many of you are confused. Many of you are going to lose marks over here. Some of you are saying C, most of you rather. Some of you are saying A. The correct answer is C, correct. Now remember this particular reaction. Say in a regular beta decay, okay, in a regular beta decay, what happens is you get, which is a beta negative decay, okay, which is an electron. You get an electron and an antineutrino. Similarly, in a beta plus decay, where you have a positron, you get a neutrino. So that's how you can remember it. For beta plus, it is neutrino and positron. For beta minus, it's an electron and negative. So anti-neutrino. So negative, anti-electron. Positive, just a neutrino, no anti-neutrino, positron. That's how you can remember it. Also remember one thing, in case of a beta negative decay or minus beta decay, what happens is over here, you will see that, the number of protons has increased. So a neutron converts into proton plus electron, proton, okay, and an electron, and you will see antineutrino. Generally the symbol for that is this one. If you rearrange this equation and you see over here protons have decreased. So when you have a proton getting converted into a neutron, so when you take this E on the other side, the negative of E will become E plus, positron, and the neutrino on the other side, antineutrino becomes a neutrino. So that's how the equation is for a beta plus decay. Okay. Zayed, Bacha, I think you are still in 12th standard, just the beginning. There is a chapter called Modern Physics towards the end, and it comes, as a, you can say, it's there in chemistry also a little bit, because these kind of things are there. And probably when you reach towards the end, you will understand this is all a part of your JEE or even your NEET syllabus. So don't worry, okay? Chill. I'm not explaining chemistry as such. But chemistry is there everywhere. Just like physics is there everywhere. Maths is there everywhere. Okay? Don't get confused. Okay, chalo, next. Let's go to semiconductors. Yep. Let's go to semiconductors. Get ready. Ready? Get set. Go. 30-second break for me to drink water. Biology is there everywhere. You are only biology. You are a chalta firta biology. Okay, without biology you cannot survive. Without any subject you cannot survive anyways. Correct? ओके चलो, तो सबसे पहले क्या है भाई, सी इन अ नॉर्मल एटम वी हैव स्टडीड इन atomic structure. You have orbits and each orbit has an energy level. You have seen that. So for an atom you will see k level, l level, m level, n level, etc etc ऐसे बढ़ते जाता है. These are energy levels of an atom. But if you have a material, एक material है, बहुत सारे atoms हैं, when you have multiple atoms you do not get energy levels. Instead what you get is a range of levels. You will get this as, let's say, the k levels of all atoms. Similarly you will get l level, many levels of all the atoms. When you have multiple levels, this is called as a band. So individual atom has level, but multiple atoms together, they interact with each other and they have series of levels, multiple levels, k level, l level, whatever, okay, and that is called as a band. Keep this in mind. Now once you understand this, see what happens is you have two kinds of bands. The one band which is completely filled with electrons, you call it as the valence band, and the one which is empty or over there, that is called as the conduction band. So what happens is you have many bands which are filled, that is the valence band, it is filled. The ones which are on the top above the filled bands, they are your conduction bands. What happens is whenever you have a material and you apply a voltage difference across that material, then the electrons, they jump from valence to conduction band because of this potential difference, and they can start conducting. Okay, so they can start conducting. But in case of insulators, there is a difference between the energies of the valence band and the conduction band, which is too much. It's a lot. So the electrons cannot jump unless you apply tremendous amount of electric field. So only for small electric fields, if it jumps, or for normal voltages, if it jumps into the conduction band and you see the electrons are moving, then you consider it to be a conductor. So an insulator will not conduct because the band gap is too less. These electrons need tremendous amount of energy to go into the conduction band. Whereas in case of conductors, these bands actually merge together. They are almost like overlapping each other. So there is no distinction between conduction and valence band. So in a way, the electrons in valence band can freely move in the conduction band. They are more like free electrons, and a small voltage also can easily move these electrons in this conduction band. Keep this in mind. But there is another kind of material in which the conduction and the valence band may not overlap. So the electrons do not have a free pass in the conduction band. There is a small gap between them. There is a small gap between them, and a small voltage can trigger these electrons over here and they can start conducting. So they are not as bad as insulators, which do not conduct at all, but they are not as great as a conductor where a small voltage is enough to start conduction, because they have a free passage into the conduction band. So this type of material is called a semiconductor. And remember one more thing, many of the electrons already will be in the conduction band already, even before you apply the voltage, and that's because, you can see that over here, that's because of something called as thermal collision, thermal collisions. So whenever these molecules, atoms interact, they collide, they vibrate, they hit each other, they knock out these electrons, and when they knock these electrons out, these knocked out electrons can enter into the conduction band, and that's because of the thermal collisions. Now, here is what happens. You might be like, sir, here also thermal collisions will happen. So why don't these electrons jump over here? The reason is the energy of the thermal collisions is even very less as compared to the band gap. So even if there is a thermal collision, this electron can probably jump till here, but that is of no use, it has to reach here. So that's why it will come back. So thermal collisions is of no use in case of insulators. Only in case of semiconductors you will see that the thermal collisions help them and allows few of the electrons to be in the conduction band. So on application of small voltages, these electrons will start conducting, but not as good as this one, because there are more electrons in the conduction band over here. Okay, so there was a question which was also asked probably, I don't know, sometime back, and it said, what happens to the resistance? Come on, let's see whether you can answer this for a semiconductor and for a conductor. Okay, semiconductor example germanium, and conductor, let's say iron or aluminium or whatever. So what do you think happens if temperature is increased? Think about it. What will happen to the resistance for a semiconductor and what will happen to the resistance for a conductor? Let's see whether you can answer this. For germanium, what do you think? Will the resistance increase or will the resistance decrease? Come on. Think. Come on, my warriors, what do you think? For germanium, will the resistance increase or will it decrease when the temperature is increased? So when the temperature is increased, what will happen? More collisions. If more collisions, these electrons will come over here. So more the electrons, because of the thermal collisions, better will be the conduction. And the moment the conduction increases, what will happen to the resistance? The resistance will decrease. Resistance will decrease, correct. Similarly, you might think, sir, now for conductors like iron, aluminium, copper, etc., what do you think should happen? If I increase the thermal collisions, will the resistance decrease? The answer is no. The reason is there are already so many electrons in the conduction band. The further increase of temperature will not increase the number of electrons in the conduction band. There are already enough number of electrons. In fact, it will be more of a trouble, because these electrons, once they get thermal energy, they will collide with each other. They will hinder their paths. These atoms will start to vibrate, and the electrons which want a free movement, they will obstruct their path. So that effect dominates, and that's why the resistance increases. Hence it's said that semiconductors like germanium, silicon have negative thermal coefficient for resistance, and this has positive thermal coefficient for resistance. Keep this in mind. Yes, so the resistance will increase for conductors, but for germanium, silicon, etc., which are semiconductors, the resistance will decrease because of thermal energies which are provided to these electrons which jump into the higher orbit. Everybody clear? Clear about this? Shushmita Bacha, I started at 9 o'clock. Now we are reached modern physics ka last part, which is semiconductors. Okay. Now you can greatly affect the conductivity of a semiconductor by doping it, by adulterating it with impurities. Now a semiconductor like germanium or silicon, which is free of any impurities, is called as an intrinsic semiconductor. It's pure. It's fully made of the similar kind of atoms or molecules out there. There is no adulteration in that. But the moment you adulterate it, then it is called as an extrinsic semiconductor. It is doped, it is adulterated with a suitable impurity to increase the conductivity, and that is called as externally you have changed something by doping it. You have doped it by an external factor. That's why it's called as an extrinsic semiconductor. Now, for this N-type, what you do for N-type, you think about it. N means negative in a way. So you add one extra electron. You add one extra electron by, having atoms with pentavalent impurities. Like, bismuth or even phosphorus. All of them, they have pentavalent impurities. So that gives one extra electron. Think of it this way, guys. See, normally your silicon will form a bond, example silicon or germanium, on all the four sides. Each bond has two electrons each from its neighbor. Every silicon has, it forms a bond. Okay, now just imagine the same thing is there everywhere. It's a big chain. There are two electrons in each bond which is formed, which is covalent. Just imagine you add some pentavalent impurity, like say for example, phosphorus. Now this will form a bond. This will also form a bond. Okay, this will also form a bond, but there will be one extra electron over here. Okay, do you see that? There is one extra electron. So this is N type of impurity. Similarly, if you have impurities which are of P type, like aluminium, okay, or boron. So if you have aluminium kind of impurity, it has one less electron, or it has trivalent impurity. So it will probably expect one electron somewhere over here, and I can show two dots over here everywhere except over here. This is called as a hole. This is called as a hole. That's the extra, I would say, there is a demand for an electron, or there is a vacancy. So there is a vacancy for an electron. Over here, you can clearly see this is an extra electron which is there, which is making it, N type of semiconductor. Okay, so keep this in mind. Yep. Very good. So hole is when there is a vacancy. Electron or N type is when you have an extra electron in that orbit, so which is free to move around. So when you have this extra vacancy or extra electron to roam around, you will see the conductivity increases, because the moment there is vacancy, it wants to fill it up, so it will ask other electrons to fill it up. So the conductivity increases. Similarly, when you have an extra electron, that electron wants to roam around, wants to form a bond somewhere, so again the conductivity increases. So that's how you change the conductivity of semiconductors. Now, very, very important formulas, very, very important, coming to diodes and all of that. These two formulas are very, very important. This N represents the density, the number density of either electrons or holes. How many electrons are there per unit volume? For example, 10 to the power 20 electrons per meter cube. That is nothing but Ne. Example. How many electrons are there per meter cube? That is called as the number density. Now, this law is very important. Ne into Nh is Ni square. What does this mean? Number density of electrons into number density of holes is always going to be equal to number density in an intrinsic semiconductor that will be given to you. Don't worry about it. It will be given to you, or either this and this will be given and you will be asked to find out this. So the number density in the intrinsic semiconductor. So guys, think about it and tell me, in case of N type, who will be more? Holes will be more or electrons will be more? In case of N type of semiconductor, who will be more? Ne will be more than Nh, or Nh will be more than Ne? Think about it and tell me. Ne will be more than Nh, or Nh will be more than Ne? Electrons will be more. N type. Correct. In P type of semiconductor, what you will get? Ne will be less than Nh. Okay, it will be less than Nh. Think about it. Holes will be more. But in case of intrinsic semiconductors, you will see Ne will be equal to Nh, and this is only called as Ni. Okay, this only is called as Ni. Keep this in mind. Clear? Okay. Now, one last thing over here, formula wise, the conductivity of any kind of semiconductor, be it N type, be it p-type or be it intrinsic, doesn't matter. This is the formula for the conductivity. Remember, there are two terms. The first term and the second term represent conductivity due to electrons. This is due to holes. So very, very important. In any kind of semiconductor, you know, the conduction happens not only because the electrons are moving, but also because the holes are moving. This is different from a normal conductor. If you recollect, in case of a conductor, like say for example aluminum or copper, you know, when you had a wire, it's only the electrons which move. It's only the electrons which move. The nucleus stays as it is over there. There is no movement of holes. Remember, there is no movement of holes. The protons, the nucleus stays there. So in a conductor, electrons are responsible for conductivity. In case of a semiconductor, electrons and holes both together contribute in the conduction. Keep this in mind. Yeah. So Ne is again the concentration of electrons per unit volume. E is the charge. NH is the concentration of holes. E is the proton charge, which is the same. Mu E and mu H, these are called as the mobilities of electrons or holes respectively. So what is mu? Mobility. Mobility of electron or hole. Like, sir, what is that value? Who will give me that value? Don't worry, they'll give you the value. We'll solve a question also based on that. Okay? Don't worry, those values will be given to you. You don't have to remember it. Even any NH values will be given. You will see a question, guys. Everybody written this down? Clear? Shall we go ahead? Come on, let me know, my warriors. Manan Hada says, oh my god, he is already scared and like, oh my god, sir, please, I want to go visit my washroom looking at these formulas. Manan, see it now so that you don't visit the washroom during the examination. Okay, chalo. Next. Okay. See, whenever you have p-type and n-type, what happens is, see, P has vacancy, N has excess electron. This guy wants something. What does he want? Electron, vacancy. This guy has excess electrons. The moment they meet, what will happen? He'll be like, oh, you want electrons? Like, yeah, I want electrons. Do you have more? Like, yes, please take it. So, the moment they meet, they form a junction. The electrons start diffusing. They start diffusing from the n-type to the p-type. And the holes will get covered up, patched up. The moment electron leaves from here to here, it will create a hole. It will create a vacancy. Yeah. Don't say that, sir, electron was excess. Actually, it is not an excess. Understand? It was just there. It was not able to form a bond. That's it. So the electron will move here, it will create a hole. So that's why I say holes move here, electrons move there. Okay, let me see if you can answer this question. If I have an n-type material, is it positively charged, is it negatively charged, or is it neutral? N-type of semiconductor. This is n-type of semiconductor. Is it positive, negative, or neutral? Come on, let me see if you know this. Chapla saying negative, Shruti saying neutral, Srija saying neutral. Glad you guys said neutral. It's not negative. A lot of people have this misconcept. Sir, n-type negative, no? P-type positive. No. It is neutral. Like, what? I just thought that had one extra electron. Yeah, but think about it. Where did that electron come from? From a pentavalent impurity, like phosphorus. Don't you see that phosphorus will also have an extra proton in its nucleus? So actually it's balancing out. Did you just visualize that? Phosphorus-like element, yeah, it has extra electron, but there is extra proton also, right? As such, it is neutral. So hence, the answer is, it is neutral. Even be it p-type, p-type or n-type, they are all neutral. Okay, so a lot of people think this is negative connected to positive. So understand, if it was negative, instead of writing n, I would have used the word negative, right? But I'm not using the word negative because it is not negative. Understand that. Clear? Everybody clear? Similarly, if you have p-type like aluminum, you might say that there is a hole, there is a vacancy. Yeah, there's a vacancy. It's not a positive charge because aluminum also has one less proton in its nucleus. Keep this in mind. All right. Now, once you know this fact, understand the moment the electrons move, there will be a positive charge created on the n-type and negative charge created on the p-type. So there is an electric field. This region is called as the depletion layer. So because of this, what happens is, there is a barrier. See, the moment you have positive here, negative charge over here, holes won't like to go there. It will be very difficult for the holes to overcome the barrier because this is low potential, this is high potential. It has to climb up that potential barrier. So the diffusion stops the moment this barrier is created, and this layer over here is also called as the depletion region or depletion layer. But there is one more thing which happens in this depletion layer. So just observe this, guys. What just happened over here is, okay, let's say we had that n-type over here and p-type over here. Example, okay, whatever. This was n-type, I guess, and this is p-type over here. The moment from the n-type, the electrons came over here. So this became negatively charged and there was a hole created here. So this became positively charged. All right. Now there will be electric field. That electric field will be here. Because of that electric field, there will be potential difference. This will be high voltage, high potential. This will be low potential. So positive charges will find it difficult to go over there. Negative charges will also find it difficult to come against this electric field force. Now, if you think about an electron or a proton over here, just think inside the depletion layer. Just think what will happen inside this depletion layer. If by chance there is an electron or proton, what will happen? There will be force on it. Which direction? Think carefully. If, for example, there is an electron, okay, if there is an electron, field is here, so force will be that side. So that electron will move this way, correct? Inside this region. And if there is a hole anywhere, that hole will experience force in the direction of field, so the hole will move towards this side. Do you see this electron movement and the hole movement is exactly opposite to this? Here, hole was diffusing this way. Here the hole is going this way. Here the electrons were going left side, the electrons are going this way. This kind of movement is called as drifting. What is it called? It is called as drifting, my warriors. Okay, so understand, when the n-type to p-type movement happens, the moment they meet each other, that is called as diffusion. But inside the depletion layer, what you see, the field which is created because of the diffusion, the field which is created because of that diffusion, the barrier, that causes more motion of the electrons, but in the exact opposite signs, directions. That is called as drifting. Now, in a normal PN junction, this keeps on happening continuously. The whole current and the drift current are equal. The whole current and the drift current are, not the whole current. The diffusion current and the drift current are equal. The diffusion current and the drift current both are equal. They cancel each other. So, in a normal, unbiased, understand the drift is equal to the diffusion. The diffusion and the drift both are equal. So, the net current is 0. What do I mean by unbiased? Unbiased means I am not partial towards anybody. That means I did not apply potential difference across them. I'll be like, yeah, you be also at 0 volt, you also be at 0 volt. If I apply voltage difference, then I am biased, I am partial. Like, yeah, you be at higher, you be at lower. That means I am biasing them. So right now it is unbiased. So unbiased, whenever you have a diode, both the diffusion and the drift currents cancel each other. Correct. Great. Yes. So is drifting present only in the depletion layer? Yes, Vinayak. But it ends up sending those electrons into the n-type and p-type material on the boundary, and those electrons then are free to move anywhere in the n-type or p-type of semiconductor. Alright, cool. Now, talking about biasing, let me in fact show to you what happens in case of biasing. Just one second. Yeah, look at this. I hope you can see this particular simulation. I'm going to change the bias soon. Okay, let's just see what is there. Okay, this is a PN junction. It is also called as a diode. Diode is nothing but any device which restricts the current in any one direction. It allows the current only in one direction and it restricts in the other direction. Like the walls of your heart, it allows the blood to flow in one direction. So actually speaking, it's also a diode, but for the blood. Everybody getting it? Okay, बहुत ही बढ़िया. Now, see, on the left side, you can see boron, and on the right side, you can see phosphorus. So clearly, this is a trivalent, this is pentavalent. So this is n-type, this is p-type. I hope you can see this clearly. So left side, this much part is nothing but p-type, and this much part is nothing but n-type of semiconductor. Great. Now, observe what happens. Observe what happens. Okay. See, I'm just going to remove this. Right now it is unbiased because there is no current, there is no voltage difference, nothing. It's unbiased. Let's make it forward bias and see what happens. Okay, interesting. See how the electrons are moving? Electron, this is positive terminal, this is negative terminal. So once that happens, observe, this is positive terminal, this is negative terminal. So the P type, this is a PN junction, P is connected to high voltage, N is connected to low voltage. What is happening? You are just seeing the electrons are moving like this. If electrons are moving anti-clockwise, obviously the current is moving clockwise because current's direction is opposite to the flow of electrons. Everybody can think about it. I will simulate it, don't worry. Now observe this, keeping this in mind, because once I start the simulation, all these markings will go away. Okay, just observe this. See what is happening? The holes are moving towards the right side. Electrons which are coming from there, you know, they are coming like this. They are coming like this. So guys, tell me, is diffusion more or drift more in this case, in forward bias? Is diffusion more or drift more in the forward bias? Come on, think and tell me. Is diffusion more or drift more in the forward bias? Come on, my warriors. Is diffusion or drift more in forward bias? Think carefully and tell me. Yes, diffusion is more. Yes, diffusion is more. Think about it. The electrons are moving more here and holes are moving more over there. The drift will oppose this. Diffusion is more. Keep this in mind. Keep this in mind. Diffusion is more. See, electrons are, see, you guys forgot this. I just told you some time back. You know, this is p type, this is n type. The electrons diffuse. They diffuse like this. And they drift like this. They drift like this. I just told you, right, some time back. Now the total current is going this way. So who is more? Diffusion is more, drift is less. Yeah, be careful, be careful. Yeah, I think you guys got confused with the signs or something. Now, if I change the biasing, if I just change the biasing line, let's see what happens. What happens? So now let's go to unbiased mode. Now nothing will happen. There are holes over here. There are electrons in abundance on the N side. Let's make it reverse bias. The moment I make it reverse bias, observe the change. Observe it. There were holes and there are electrons. See what is happening over there. They moved away. Do you see what just happened? The depletion layer became big. It's very difficult for them to conduct. Okay, the electrons are being pulled by the positive side. The holes are being pulled by the negative side. The depletion layer will increase. No conduction happens. So that's what happens in reverse bias. Okay, great. So going ahead, yes, they are moving away. So in forward bias, there is conduction. Forward bias, there is conduction. In reverse bias, there is no conduction. Unless you apply too much of voltage and there is like, okay, give up. Okay, fine, you move, man, no problem. positive pulls the electrons, negative pulls the holes, but that happens at a very high voltage. That's called as the breakdown voltage. And especially those diodes which are used in breakdown region, what are they called? They are called as Zener diodes. So Zener diodes are used in breakdown regions. So that's one thing. So forward bias, there is current. In the reverse bias, there is no current. That means the PN junction allows the current to flow only in one direction. The direction in which the current flows is called as or it is shown with this triangular mark. Okay, so if this is the diode, this is how the triangle shows. So understand, it is always shown in the direction in which the it allows the current to be flown. Okay, great. Now I've just talked about forward and reverse biasing. In forward biasing, the P side is connected to positive, N side is connected to negative. Reverse biasing, P is connected to negative, N is connected to positive. So you will see in forward bias the diode conducts, in reverse bias the diode does not conduct. In breakdown region it breaks off and it suddenly starts conducting when it exceeds too much of voltage. Okay. So Zener diode, like I just told you, it's heavily doped, and this is specially used for voltage regulation, so that when you are in this breakdown voltage region, you will see no matter what you try to do, the voltage does not increase beyond a point. Because the voltage is constant in the breakdown region, it's also used for voltage regulation because the voltage across it does not change. So that's Zener diode, and it is always used in breakdown region. That means in reverse bias. Keep this in mind. This graph is also called as the current voltage, IV, characteristics of a diode. Going to transistors. Some important formulas only I want you to remember. What exactly is a transistor? First of all, it's basically two diodes together. Okay, it's two diodes together. First of all, these transistors, because they are two diodes together, so you can have two types of transistors. One is NPN, second is PNP. Now, the amount of doping and the size of each part is different. The one which is biggest and heavily doped, the one which is the biggest and heavily doped, this one, it's big and heavily doped, that is called as the emitter. What is it called? Emitter. Same thing in PNP also, the one which is big and heavily doped. This one in between, this is very light and thin, that is called as the base. And the one which is medium and decent in size, that is always the collector. Keep this in mind. The one which is medium and decently in size, that is called as the emitter. How do you distinguish between the two symbols? How do you distinguish between the two symbols, whether it is NP or PNP? Look at the arrow mark. Okay, just look at the arrow mark. See, if the arrow mark is like this, outward, okay, if the arrow mark is outward, it is an NPN transistor. If the arrow mark, if you see it inwards like this, then it will be PNP. And there is a better way of doing that also. Keep this in mind. Always the emitter base, no matter what you do, is always put in forward bias. Emitter base is always put in forward bias, and base collector are always put in reverse bias. Remember, I told you a transistor is nothing but two diodes in a way. Look at this, base and emitter. Look at this, base and emitter. What is base? Base is P. And what is emitter? It is N. So if you think about it, the current is flowing from the positive to the negative. It's going like that. So it is in forward bias. Think of it as if there is a battery kept over here. Okay, it is connected P to the positive, N to the negative. So it is in forward bias. So the arrow mark will be outwards. Here, if you look at this, this will be in reverse bias. It's opposite. Okay, keep this in mind. Oh, sorry, my bad. This will be also in forward bias, my bad. The emitter base, because the directions are opposite. You can check that out. Because the base is N and the emitter is P. And the arrow mark is like that. So if you go like that, emitter base will again be in forward bias. You can see that this is again in forward bias. Always emitter base is, remember, forward bias. That's how the arrow mark is that way. Okay, great. Now having said that, there are different ways of connecting a transistor. Now you might get confused, what is this common emitter, common base, etc. See guys, I'll tell you one thing. Imagine I give you a transistor like this. Okay, this is a transistor. This is, I know, the base, this is the emitter, this is the collector. Don't you see that there are only 3 terminals? Usually all our appliances have 2 terminals, be it battery, be it resistor, be it anything, switch, 2 terminals. How do you connect a transistor? Clearly, since there are 3 terminals, you need to make sure that one of those terminals is common, or it is diverged, or you bifurcate it to 2 other terminals. So hence, you always label that terminal which is made common to other 2 sides as common emitter or common base or common collector arrangement. For example, imagine somebody uses the collector. Somebody uses the collector as common. That means you connect, let's say, a battery over here, example, and take the same thing over here, and maybe, I don't know, you have some device over here and you connect it over here. So this is common collector arrangement, as simple as that. If you want to make it common base, okay, just from the base you take out 2 terminals like this. That's it. This is common base. You can keep some device here, you can keep some device here. Base is common. You can see that. So that's what these 3 arrangements are. Is that clear? Yes. Yes, collector is also decently big in size, Shraddha. Yep, it is big in size. Definitely much bigger than the the base. It's almost like the emitter, but slightly less. Okay, great. Now, what exactly does a transistor do? You might be confused. So for that also I have a simulation. Okay, you will understand this. This is the best simulation. After this, you will not have confusion. Okay guys, first of all tell me which kind of arrangement this transistor is in. Which kind of arrangement is this transistor in? Look at this. All the things are marked. Is it common base, common emitter, common collector? Come on my warriors. Nityashri, please watch my 0 to hero on waves. You can see Doppler effect. Okay, it's just search Shreyas Sir, Doppler effect. It's common emitter because you can see the emitter is common. What kind of transistor it is? Is it PNP or is it NPN? Check this out. Is it PNP or is it NPN? I'm pretty sure because the arrow mark is outside, it is NPN transistor. Perfect. Okay. Now, going ahead. What happens, guys, observe, in case of a transistor. Okay. So, if this is the base current, this is the emitter current, okay, and let's say this is the collector current, okay, actually collector current will be like this will be IC. Now somebody wondering, sir, why is collector current and why is base current like this and why is emitter current like this? Simple fact, emitter base should be always in forward bias. I have told you this again and again. Check this out. Base is P, emitter is N. Do not forget that. This is NPN. So positive to negative. This is the forward bias loop. Check this out. This is forward biased. You can check this out. Similarly, base collector is always reverse biased for normal operation of the transistor. So this is P, this is N. So you can see the current is coming in like this. So it's coming from N to P. So that is reverse bias. So this loop you can see it is reverse bias because it is going from N to P. Cool? Great. Now that's how I decided the arrow marks. Obviously by Kirchhoff's current law, at this junction, because this is also junction, can you not see that the emitter current will be equal to the base current plus the collector current? The emitter current will be the base current plus the collector current. But what happens is the base is very lightly doped. The base is very thin, because of which this base current is very, very small. The base current is very, very small. And this emitter current is roughly equal to the collector current. Roughly, I'm not saying it's equal. A collector is slightly less because it is on the RHS. It is almost equal. Now, this helps us understand the functioning of a transistor. And I have created, or I'm using a mechanical analog to explain you the working of a transistor. Base current is small, emitter current is the biggest, collector is decently big. Base current changes the emitter current, and that's what you're going to see in this particular simulation. Right now, the base current, this is the base, this is the emitter, this is the collector. These are two barriers. If I open this, there are gears that will indirectly open this. The balls will start falling here. The balls will start dropping from here. Base and collector together will give you emitter. Agreed? Base plus collector together will give you that emitter. That's what I want you to see. Observe this now. I'll just change this. Look at that. Look at that. A small base current and that collector current is creating a big emitter current. If I vary base current, I can indirectly change the emitter current by a large amount. So what is happening? What is happening is small variations in base current can create tremendous changes in emitter current. That's why transistor is used in amplification process. Small current changes can create big change in the emitter current. You can see that. Okay, got it. Yeah, so that's how it works. Clear? So after this, probably you will not have any much of difficulty understanding what is the basic idea of a transistor. Even if you know that, that's enough. Okay, so this is the same thing via electrical analog, but don't have to remember this so much. Just remember the base current is small, the collector current is decent, base and electron current together give you the emitter current. Now the two characteristics of a transistor, alpha and beta, very easy to remember. Very easy to remember. I'll tell you what. Collector, I have told this again and again. Collector is a government post. It's very high post, respected post. So collector will sit on the top always. Be it alpha, be it beta. Collector will always sit on the top. If it is beta, what is similar to beta? B. What is B? Base. So it will be base. That's beta base. Alpha, the only thing which is remaining, that is emitter. So emitter will be over here. So that's how you can remember alpha and beta values. As simple as that. Isn't it amazing, guys? Now you cannot forget this for sure. Gauri Shankar, you will get the session PDF after some time. I'll send this PDF to Vani ma'am and the team. They'll upload it on the Telegram group and hopefully on the description box as well. Cool. So never ever forget this. Now guys, I'm going to show the problems. It will be so easy for you. Trust me, after this you will really feel confident about yourself. But before that, all these gates and NOR, all these gates, guys. So how do you understand these gates and what are these symbols? I'm going to tell you one simple technique for this as well. See, let me just probably use this board, hopefully. Oops, where is it? Yeah, okay, cool. See, if you have an AND gate, do you see this D? Do you see this D, guys? That's it, that's the symbol for that. That's the symbol, that's the AND gate. Okay, never ever get confused again. If I say not, do you see this O? Do you see this O? So just put that O over there. That's it. That's a NOT gate. Simple? Okay. Then you have the OR gate. OR gate. So the OR gate is like this. Probably you can think of R this way, and you don't need this. So but just think of that R over here like this. One crazy symbol R. So this is your OR gate. As simple as that. Everybody fine? Great. Now, how do you write the truth table? A lot of people get confused. Sir, how do you write the truth table? It's very simple. See, for AND gate, Okay, so these are the inputs. X and Y are the inputs. This is the output. So how do I write those inputs and outputs? Whenever you think of AND, think of some statement like, for example, Manu and I don't know, maybe Sakshi. Okay, Manu and Sakshi. Just taking some examples, don't mind it. Okay. Now, here is what you can do. Manu is very, very, you know, dashing. Manu is, I'll make this statement. Manu, I'll just make this statement. Manu is dashing, and I'll put some word over here, and one more word, rich, maybe, rich. So dashing is like yo types, cool, very cool, and rich. They are two different things. So if I see that Manu is dashing and rich, if I see 0, 0, that means Manu is not dashing, very boring guy. He's not even rich. Is Manu dashing and rich? The answer will be no, 0. I check, Manu is not dashing, Manu is not rich, so Manu is not dashing and rich. Understand that. I ask Manu, is he dashing, or check on Manu. Manu is not at all dashing, but Manu is rich. Is Manu dashing and rich? No. I check on Manu. Manu is dashing, but is not rich. Is Manu dashing and rich? No. I check on Manu. I see he's dashing and he's rich. Yes. Then he is dashing and rich. So 1 and 1 is 1. That's how it works. Simple? Cool. Similarly, for not, whatever is the input, it negates it. It will just be like ulta. It's like one disobedient student. If you say go play, the student will go and come and study. If you ask him to go study, he will go and play. If you ask him to jump, he will sit. If you ask him to sit, he will jump. So that's a not gate. He will do everything reverse. Ulta khopdi. This is ulta khopdi. Okay, what is this? Ulta khopdi. Okay, this one or. Again, same thing, guys. X, Y inputs. This is my output. This is X, this is Y, this is my output. If I put an OR symbol over here, Manu is dashing or rich. I check on Manu, Manu is not dashing. Manu is also not rich. Is Manu dashing or rich? No. Manu is not dashing, Manu is rich. Is Manu dashing or rich? Either one of them? Yes. Manu is dashing, but he is not rich. Is Manu dashing or rich? One of them? Yes. Okay. Is Manu is dashing and rich both? Is Manu dashing or rich? Oh, he is both. So at least one of them is there. So that's how it works. 1 and 1. 1 or 1 is 1. Okay. Clear? Great. Okay. Great. Cool. Now it's easy. Now you might also have NAND gate. See guys, you might also have NAND gate somewhere. If you put a NAND over here, N over here, it's nothing but just negate it. 1, 1, 1, 0. That's it. That means there will be a dot over here. That's all the meaning of NAND. If you see a NOR somewhere, that means put a dot over here and just negate it. So this will be 1, 0, 0, 0. That's a NOR gate. Everybody clear? Lemon squeezy, easy peasy. Okay. Yana bacha, halfway full wave rectifier, just study it from, NCERT. That's all. Okay? Just look at the questions and how to solve these previous year questions. That was more than sufficient. You can check out how that half wave rectifier, everything works. That's more of theory part. Okay. So, having said that, let's see whether you can start solving the questions. We have come to the final part, and that's questions. Let's see if we can get this. This is AIPM 2007. The energy band diagram of a material is shown. Open circles are holes, filled circles are electrons. The material is insulator, metal, N-type semiconductor, P-type semiconductor. Come on, think about it. Okay, D. Okay, very correct answer D, because you can see that even when these electrons will jump back, okay, even if they fill this up, you will see that there are empty places over here. What are these? Holes. And if you have holes, it clearly means it is p type. If there are more electrons, then it would be n type. Okay, if I count, there are more electrons over here, many electrons. Even if they fill, you will see some excess electrons, then it will be n type. Okay, cool. Next, a forward biased diode is, which of the following is a forward biased diode? Come on, think about it. And guys, if you have forgotten to smash the like button for this amazing lectures, please go smash that like button right now. And if you're new to this channel, go hit the subscribe button right now. Okay. Glad to know that, Saujanya. Okay, A for sure. Very good. Excellent, my warriors. The answer is A, because this is high, this is low, this will conduct electricity because this is P, this is N. It will conduct, this is forward. Everything else is reverse. This number, be careful, this is low, this is high. All these three are reverse bias. Okay, beautiful, excellent. Going ahead to the next question. In a NPN transistor, it will conduct when which of the following is true? Only one of them is true. Come on, my warriors, figure this out. Only one of them is true. Think about it. Shreyas Kumar saying A, Reshma saying C. Anna, thank you so much. Yes, Khurram, universal gate is that gate which can take care of any kind of operation, and those are NOR and NAND gates. You can make any kind of gate using NOR and NAND. A or C? Well, many of you are wrong. Guys, the answer is B. See, in an NPN transistor, let's just draw it for now. This is like this. This is base. This is collector. This is emitter. But if you talk about NPN wise, this is N, this is P, and this is N. We know that emitter base junction should be forward bias. So that means the current should flow like this. And base collector junction should be reverse bias. So the current should flow from the negative to the base. That's how it is. So if you think about it, if the current is going like that, in case of a base emitter, the collector is positive and emitter is negative with respect to the base. If I take the base, okay, if I take the base as 0 volts, example, think about it, if the current is coming like this, okay, the current is coming like this should be positive volt. Think about it, this should be high volt, this should be high voltage or positive volt. So that's why the current will come like this. N is connected to positive, P is connected to lesser voltage. Here, this is forward bias, the current is going like this. So this will be low voltage or negative voltage. So N is connected to negative, P is connected to relatively positive. Hence the correct answer is B. I hope now it makes sense. Got it? Got it? Clear? Very good. Chalo, next question coming up on your screen. Thank you, Manandana. Thank you, Ritesh. Shruti, there are different ways to increase speed in physics. Calculations you can increase. You can solve variety of problems so that you are not surprised in the examination. Then also making sure that you do not write all these steps, but all the important stuff only in rough, not writing it very neatly, but do not make mistakes. And also sometimes by elimination, and sometimes by using some logic that okay, this option makes more sense, and speeding up the calculations or somehow eliminating using some physics theory or logic or some gut feeling. So sometimes that also works. These are the different things you can do. Okay, Chetan, you can do one thing, you can just rewind back the part and you can watch it again. Okay, let's continue with the session. You can just go back after some time or even after the session is over. Okay, Great. Shana, the calculations become fast when you actually do the calculations without calculator at home. That's all. And keep doing mental math. Don't use calculators. Know all the tables. Do all the divisions, multiplications, additions, subtraction at home on a piece of paper without using any help. And make sure you know the tables, squares, square roots, logarithms, all of these. Okay, the conductivity, I just told you, it is Ne mu E plus NH mu H into E. So E is common, so Ne, what is Ne? Electron concentration 5 into 10 to the power 18. Mobility, mobility of electrons is 2, okay, plus NH, whole concentration is 5 into 10 to the power 19, and mu H is 0.01, and this into 1.6 into 10 to the power minus 19. Come on guys, you can do this and see what you are getting. A lot of you are saying A, interesting. Think, come on, do this math. You should be able to do this. This is 5 2s are 10. 10 into 10 to the power 18 is 10 to the power 19, plus this is 0.05 into 10 to the power 19. This whole thing into 1.6 into 10 to the power minus 19. 10 to the power 19, if you take out common, it will get cancelled from here. So you will be left with 1 plus 0.05 into 1.6, which is 1.05 into 1.6. So it will be slightly more than 1.6, slightly more. So obviously it will be A. So you don't have to sit and multiply it. Somebody was asking, sir, how do you speed up calculation? I did not multiply it. Why? Because I know it will be slightly more. 1.6 into 1 is 1.6. 1.05 into 1.6, slightly more. So directly mark it. Why do you want to break your head? Got it? Cool. Chalo. Let's get going to the next one. So these kind of questions do come, guys. You should be able to do it after this. Never ever lose marks in semiconductors after that. Okay. Cool. Next question coming up on your screen. In an NPN transistor, you have the collector current. You have 99% of the electrons from the emitter which reach the collector. Then the emitter current and the base current respectively are. Interesting. Come on, my warriors, figure this out. What would be the emitter and the base current? Options are there on your screen. 99% of the electrons which reach the emitter are from the emitter reach the collector. That's what is given. Interesting. Dhruti saying B. Ragodhanam, I will reply, Vacha. Give us some time. Don't expect me to reply everything instantaneously. Sometimes it depends. I happen to respond just because I'm on the video or I'm doing something. But don't worry, I'll respond to all your queries. Okay? Don't worry. Okay, B for sure. Let's see. The correct collector current is 9.9, and this is given to be 99%. That means 0.99 of IE. It's clearly mentioned. It is 99%. 99% of emitter current. So IE, obviously, take that over there. So it will be 9.9 divided by 0.99, which is 10 but milliamperes. Lastly, if I know emitter current, I know base current plus collector current gives me emitter. So 10 is equal to base, I don't know, collector 9.9. So IB will be 0.1 milliampere. So that means it should be 10 and 0.1. So it's option C. Many of you said B for some reason. Guys, it is C. Be careful. Many of you said B. I don't know why you said B. It's not 1. It's 0.1. Be careful. 10 minus 9.9 is 0.1. It's not 1. Okay, you made a silly mistake. If somebody had asked you what is the value of alpha and what is the value of beta, remember I gave you the technique. Always collector on the top, and it's a base and beta together. So this is how it works. Here you will get IE. So IC by IE. Collector is 9.9. 9.9. I know it is not asked, but I'm just showing it to you. And emitter current. What is emitter current? 10. So this will be 0.99. That is what alpha will be. And if somebody asks you beta, it will be collector by base. Collector. 9.9. What is base? Base is 0.1. So this will be 99. That's how it is. Very good, Yalini, very good, Chetan. Excellente, excellente. So that's how you need to solve these problems. After this, I'm pretty sure you'll not face any difficulty. Next few questions on logic gates. Come on, my warriors. The following diagram shows which kind of gate. Effectively, when you do this, what kind of gate it is? By the way, when I show this over here, it is actually like this. Okay, it's going like that. Okay, think about it. What kind of gate it is? Is it AND? Is it NAND? Is it OR? Is it XOR? Come on, figure this out. This arrangement, I don't know whether you know what happens. Keep this in mind. If you have a gate like AND, and if you short both of them, okay, if you short both of them, then what will happen? 0 and 0, 0 and 0 will give you 0, but not of that will give you 1. Not. Similarly, if you had 1 and 1, because the same thing will go on both sides, 1 and 1, 0, not of that, 0. So you can see this is nothing but like a NOT gate. So NAND gate which is shorted is nothing but a NOT gate. Keep this in mind. So this diagram will now simplify to this and a NOT gate. Two NOTs will cancel out, it will nullify. Two wrongs make a right? So same way, you will see it's just nothing but an AND gate. So hence the answer is A. Beautiful. Got it? So this is the simplification process which you can do and solve the question. NOT and NOT will nullify the effect. So the answer is A, which is AND. Going to the next question coming up on your screen now. AIPMT 2006, there are signals given 0, 1, 0, 1, etc. Output is also given. C is the output, A and B are the inputs. The question is, what kind of gate do you think this output resembles to? Let's see how many of my warriors get this. Very, very interesting. A, B and C. Just check the inputs and the outputs. If you look here, this is 0, this is 0, this is also 0. So 0, 0 gave me 0. Interesting. This is 1, this is 1, this is 1. So 1, 1 gives me 1. Interesting. This is 0, this is 1, this is 0. Okay, so 0, 1 gives me 0. Cool? Over here, this is 1, this is 0, this is 0. So 1, 0, 0. So what kind of gate it is? Isn't it obvious now? Isn't it an AND gate? Zeros and 0, 0. 1 and 1, 1. 0 and 1, 0. 1 and 0, 0. And both should be true. Both should be true. AND gate. Correct. So that's how you need to solve it. It's not difficult. Trust me, guys. If you just revise the theory after this lecture, you will find it easy. Just focus on solving problems. Don't focus too much on theory now. Focus on applying those formulas and the theory. That's what you need. And if you want more such practice, trust me, you should check out the crash course link which is there in the description box, because all our top scorers, all the people who have scored amazingly well are from Vedantu. And let me give you some statistics. Even in JEE, 4 out of 5 students are already qualified for JEE Advanced. That's interesting. And the national average even in the board examinations is 5 to 7 times higher than a student who is not studying in Vedantu. So, you are not only going to get the entire syllabus lectures, recorded plus live, whatever you want it. There are 120 sessions from teachers like me. Also, there will be doubt solving from morning till night. Not just that, you need practice. So, remember I had given one strategy session, you need to practice and use this part syllabus and full syllabus test series. Not just that, also if you find there is a difficulty in particular chapter, you can watch the recorded lecture anytime, revise it as many number of times as possible. So you have the learning module with assignments, live classes, recorded classes, you have the tests and you will get the reports. And to boost your performance, you need to make use of the doubt solving facility, and there will be special strategy sessions only for, not even on YouTube, only on the crash course. So the usual price used to be 10,000 rupees, but you get 55% off and you get it for 4,500 rupees. So all you need to do is, if you're watching this video right now, so let's say you're on this channel, okay, and right now if you are over here, and that's me, interesting. So you can see that there is a link for registering for pro subscription, that's for the droppers batch, and if you want the crash course, this is where the link will point you to. Although the batch has started some time back, but it is okay, you can still join it, you can watch the recorded classes, don't worry about it, and make sure that you use the coupon code SHNEET, so that you get that 55% off. And the reason why I'm telling you you should take this up is because you cannot be completely dependent on YouTube. If you think that YouTube is going to save me, no, frankly speaking, no. YouTube plus the crash course, yes. Only the crash course, still yes, but YouTube plus crash course is the best combo that you can think of. So don't be completely dependent on YouTube. Don't think, okay, I'll learn this lecture in this channel, I will learn this lecture from that channel, and that way I'll be able to complete the entire syllabus. If that's your mentality, it's not going to help. Let me tell you that it doesn't work anytime. So you need to get your doubts solved. You need to make sure you have those test series in a planned manner. Don't risk it, guys. Even in the last few days, you never know, things can change. I would be really excited to see you over there, and I would be really happy to see your ranks improve, marks improve from whatever you think you are getting right now. Yes, thank you for all the love. Do not forget to smash the like button down there. I would be really interested to see all your comments after the video ends. I'll be reading it personally. I know I might not respond to all the comments, but trust me, I'll read all the comments that you put up anywhere, okay? So thank you guys for being here. Thank you guys for tuning in live. And those of you who are going to watch it recorded, please make sure you watch it properly. And also one more thing, I'll be coming again after the JEE Mains examination is over very soon for more mock tests, for more important sessions, topics, etc. Whatever you need, just let me know in the comment section. I'll be there. Okay, that's it from my side. This was Shreyas here, your physics master teacher at Vedantu. Hasta la vista.